Okay. So good evening, everyone. Yeah, will the recordings be available if offline classes starts? That I didn't know, but I'll ask them to say. But yes, GATE 2022 online application data has been changed, and online application starts from 2nd September. Okay. So yesterday we discussed about the Rankine's theory. Yesterday we discussed about the Rankine's theory. Now we will see the Terzaghis theory. Now we will see the Terzaghis theory. Okay. As we already know that Terzaghi is a father of soil mechanics. Okay. And Terzaghi was the one Terzaghi was the one who has introduced the effective stress concept. Yes or no? So now, according to Terzaghi, how you are going to find out the ultimate bearing capacity? According to Terzaghi, how you are going to find out the ultimate bearing capacity? Okay. So first thing first, he has some assumptions. So what Terzaghi says is soil fails by general shear failure. Soil fails by general shear failure. Yeah. And second point is, whatever the base of footing, you see, he assumed, Rankine assumed a base of footing is going to be smooth. But Terzaghi says that actually this Terzaghi is nothing but modified Prandtl's theory. After Rankine, there is a one person known as a Prandtl, and that modified Prandtl theory is nothing but the Terzaghi's theory. So Terzaghi said that whatever the base of footing is there, it is not going to be smooth, it is rough. Base of footing is rough. Okay. And come to the next one. So let me take a foundation. Anyways, as I am discussing first point, point number one, when I say the general shear failure, you tell me, yesterday we discussed about that the general shear failure and local shear failure can be seen in shallow foundations, which means the Terzaghi theory is applicable for shallow foundation or deep foundation or both. It is applicable only for the shallow foundation. So if we take a foundation, let's say this is a foundation. This is the ground level. And whatever the base of footing, this is the base of footing. Okay. So now what is what says from this from means you know that whatever the load that you apply, that load is assumed to transfer at the base of the footing only. Yes or no? And you see here, this is nothing but the backfill. So whatever here, that's nothing but the backfill. And let's say the depth of the foundation as D. So this is nothing but depth of the foundation. So whatever the depth of the foundation is D. So now if you observe here, whatever the load that you apply, in the case of the shallow foundations, we assume the load is taken by the soil. Yes. So we assume the load is going to be transferred to the base, which means whatever the soil beneath the footing is able to resist the load. Whatever the soil beneath the footing is able to resist the load. And whatever the soil above the footing is just considered as surcharge. What is that? Whatever the soil above the footing is just considered as a surcharge. So here the soil above the base of footing, the soil above the base of footing is considered as a surcharge, gamma D. And whatever the resistance of the soil mass above is neglected. See, simply above gamma is there, and whatever the soil now, instead of taking that, what Terzaghi says that self weight of the soil mass acts as surcharge at the base of the foundation. Self weight of soil above the base of footing is considered as surcharge at footing level. So which means as the side resistance has been neglected. Whatever the resistance of the soil mass on a side has been neglected. And next one here is, you know that the soil fails by general shear failure, base of footing is rough, and obviously whatever the soil, you see, when the footing is going to be settles down, now you know that's a passive state. Yes or no? Passive equilibrium condition. Passive equilibrium condition exists. So these are all the assumptions made by the Terzaghi. Okay, fine. And you know it very well. What is the meaning of the general shear failure? Yes or no? What is the meaning of general shear failure? You see, the meaning of general shear failure, the shear surface the shear surface is going to be travel up to the ground level or not? Yes. So now if I draw the shear surface, if I draw the shear surface, okay. So now, as I already mentioned you, it acts as a surcharge. Yes. So if I draw the shear surface, how does it look like? The shear surface, and if B is going to be the width of the footing. Now, if I draw the shear surface first extends up to the base of the footing. So whatever the footing, it tilts, and then shearing is going to be happen up to the ground level, up to the ground level. This is one side. Similarly, this is on the other side. Okay. So you can observe there is a shearing up to the ground surface. There is a shearing up to the ground surface. So it was given by the means general shear failure. But anyways, the resistance that is going to be developed, you know that whatever the soil mass above the base of footing, they are just considered as self weight. So now this is how the shearing is going to be expressed on one side. If it happens on right side, it looks like this. If it happens on left side, it looks like this. Okay. And now you can ask me, sir, up to what depth the shearing is going to be takes place, sir? Up to what depth the shearing is going to be takes place? The shearing is going to be takes place up to a depth of, so whatever this is here. The shearing is going to be takes place up to a depth of exactly equivalent to width of the footing. Width of the footing. Okay. So tilting will happen only one side. So that's what I am saying, my dear. So why it is passive? Or if the footing is moving towards the soil, wall moves towards the soil, passive state, right? So passive equilibrium condition. It's not passive plastic equilibrium condition. Passive plastic equilibrium condition exists. Passive plastic equilibrium condition exists. So now, if you observe over here, so whatever the soil above the footing acts as a surcharge, and beneath the footing, the shearing is going to be takes place. Beneath the footing, the shearing is going to be takes place up to the width, up the depth, up to a depth which is equal to the width of the footing. Now you see, observe here carefully. When the soil is going to be tilted first, means in this zone the soil will undergo compression. In the first zone, so in this zone, whatever the zone I am representing, this zone, the soil will undergo compression. Soil undergoes compression, but when it tries to move in a lateral, it is prevented from lateral movement. This is a zone 1, which we call it as elastic zone. Zone 1, which we call it as a elastic zone. So what happens in the elastic zone? Soil gets compressed and prevented from lateral movement, results in elastic stage. So whatever the soil beneath the footing, we are going to see that one as an elastic zone. So now if you observe, see from here onwards, you please observe, when the soil tries to move this side, whatever this will prevent the lateral movement. But once the soil from here onwards, once the soil try to go, so now from here onwards, the soil tries to shear. From here onwards, the soil tries to shear. And while it is shearing, the shear is going to be fully mobilized, and at some point it is going to be failure. You know, in the case of passive state, if you remember, in the case of passive state, the angle made by the failure plane makes 45 minus 5 by 2. Remember that? 45 minus 5 by 2. Okay. So whatever the angle made, now eventually after the shearing, at some point, the soil starts to fail. Whatever, this is nothing but a failure. And whatever the angle made by the failure plane, here it is nothing but 45 minus 5 by 2. So these zones are known as, this is a zone number 2, because on both sides where the shearing is going to be start, and while shearing is going to be happen, every particle in the soil reaches plastic equilibrium due to the passive state, and the failure is going to be takes place. And this zone is going to be the passive zone. And at this zone, in the passive zone, the angle made by the failure envelope is 45 minus 5 by 2. So there are 3 zones overall. So number 1 and number 2 and number 3. So what is the second zone, sir? All these things was said by Terzaghi, not by me. Zone 2. Radial shear zone. So what is mean by radial shear zone? Soil starts to shear in all radial directions. Okay. See, for us, this is one radial direction, this is one radial direction. If you see the lengthwise also, there is a radial shearing. So beneath the footing, after the elastic zone, the soil starts to shear sides. Radial directions. Now, the third zone, zone 3 is passive zone. So what is this passive zone, sir? In this case, while shearing, 45 minus, if it is a passive state, 45 minus, go back to the earth pressure theories I told you. So while shearing, at one point, soil reaches plastic equilibrium and fails by making an angle 45 minus 5 by 2 with respect to horizontal. Okay. 45 minus 5 by 2 with respect to horizontal. So first one, there is no shearing. In the first zone, it is elastic zone. And then the radial shearing has started. And then finally it reaches the plastic equilibrium, elastic to plastic. So these are the 3 zones explained by the Terzaghi. And after the entire discussion, he has given an equation for the strip footing. Okay, so what is the equation he has given is for strip footing? See, whatever the equation I am going to give you, this is for the strip footing only, because almost all the model analysis was done on the strip footing. Almost all the model analysis was done on the strip footing. So in the case of the strip footing, now QU is equals to, what is this strip footing says is CNC plus gamma D NQ plus 0.5 gamma B N gamma. CNC plus gamma D NQ plus 0.5 gamma B N gamma. Sir, what is this, sir? You please observe the entire C. C represents for the total soil. C represents for the total soil. Okay. Next, gamma D is there, right? Gamma D is nothing but what is the pressure of a soil above the base of footing, which is nothing but surcharge, right? I told you whatever the soil above the base of footing is surcharge. So that is known as a surcharge effect. And what about gamma B, sir? The gamma B means, Are Baba, below the footing, up to what depth I am considering the below the footing, up to what depth I am considering the shearing? I am considering B. So below the footing, at this point, what is the pressure? Below the footing, at this point, what is the pressure? Forget about surcharge. You can feel gamma B. Yes or no? So how many things are there here? For the total soil, there is a cohesion. And above the footing, there is a surcharge. Below the footing, there is a soil of depth B. There are three effects. So what I am going to do over here is, instead of representing this one as a total equation, I will cut down into some parts. I'll call this one as cohesion effect. Cohesion, C, cohesion effect. And I'll call this one as surcharge effect. Surcharge effect. And I'll call this one as a width effect. So the second one is either surcharge effect or depth effect also we can say. Okay, so cohesion total, gamma D above the base of footing, gamma B below the base of footing. Now you may ask me, sir, then what is the 0.5, sir? You see this 0.5, it's a factor representing the type of footing. For a strip footing, the factor here is we call it as a shape factor. We call it as a shape factor. We call it as a 0.5. What we call? So that's a shape factor for strip footing 0.5. Okay, sir. Sir, you said that C cohesion, gamma D surcharge, gamma B width effect. But what about this NC, NQ, N gamma, sir? The NC, NQ, N gamma are nothing but bearing capacity factors, which depends on the angle of internal friction. What is this NC? NC, NQ, N gamma are bearing capacity factors that depends on angle of internal friction. That depends on angle of internal friction. So overall, do you need to remember this as a whole formula? No, you don't need to. I can remember as a three parts: cohesion effect, surcharge effect, width effect. Cohesion C, surcharge gamma D, width gamma B. So cohesion bearing capacity NC, surcharge bearing capacity NQ, and width N gamma. And if it is a strip, it is going to be 0.5. Okay, so the Terzaghi has done his analysis on strip footing only. Sir, why you show dotted lines above the base of footing? Why? Because whatever the resistance you are going to see now, the resistance, side resistance is neglected. See, you know that when the shearing is going to be happen like this, then there must be some resistance, right? When the shearing is going to be happen like this, then there must be some resistance. And you see on the top, the resistance we neglected. Side resistance has been neglected. That's why. Okay. If you want, I can show you that too. The resistance. Whatever, this is nothing but resistance. And side resistance has been neglected. So after all this discussion, now what is the equation finally? CNC plus gamma DNQ plus 0.5 gamma N gamma. And this is the wholesome equation. I'm telling you, and I am going to say this also. In this chapter, this is one equation that you need to remember. And all the others are alterations or modifications. Please give me a minute. Okay. Yes, there is a shearing, there is a heaving. Heaving will be takes place at the ground surface. You can observe a slight amount of the heaving would be there. Okay, heaving would be there, but we are not seeing, right? So that's the reason why we are not taking the soil mass above strength. Okay. So now, once I know the ultimate bearing capacity, what is the design condition yesterday I discussed with you? What is the design condition? I hope you people have gone through the notes. What is the design condition I explained with you yesterday? I explained you whatever the gross pressure from the structure should be less than or equals to safe bearing capacity, or net pressure from the structure is less than or equals to net safe bearing capacity. So if you know the ultimate bearing capacity, then you can find out net ultimate as ultimate minus gamma d. And you can find out the net safe as net ultimate by factor of safety. And if you find that, you can find out the safe as net safe plus self weight. Fine. So this is the equation. Now let's see the modification. Sir, you are saying the NC, NQ, and gamma are bearing capacity factors that depends upon phi. Sir, in examination, will they give NC, NQ, and gamma, sir? Yes, they will definitely provide you NC, NQ, and gamma, except for clay soils. Why? Because in the case of the clay, for clay, phi is equals to 0, right? For clay, the values are fixed. Let's see that. See, the NC is a function of phi. NQ is a function of phi. N gamma is also a function of phi. Phi means angle of internal friction. Phi, angle of internal friction. So all these NC, NQ, N gamma are the functions of angle of internal friction. Functions of angle of internal friction. Okay. So now, if you observe, for clay soils, phi is equals to 0. When phi is equals to 0 degrees, then what is NC, what is NQ, what is N gamma, sir? The NC, for NC, there are two values, 5.14 and 5.7. So what is this 5.14 and 5.7, sir? NC depends upon the base of the footing. If the base is smooth, then we say it as a 5.14. Base of footing smooth. And if the base of footing is rough, if the base of footing is rough, then we call it as a NC 5.7. So what Terzaghi mentioned is the base of footing is rough. See, you have to remember this one clearly. You have to remember this one carefully, because in examinations, they sometimes say, assume the base of footing is smooth. Assume the base of footing is rough, or else, as per Terzaghi, base of footing is rough. And what about the smooth, sir? This was given by Prandtl, my dear, not Rankines. I told you Terzaghi is a modified version of the Prandtl. Yes. Why? Because Prandtl assumed, means Prandtl has done the same thing, but Prandtl assumed base is smooth. But if the base is smooth, it is not a rigid foundation. The base should be rough so that it is going to be act like a rigid foundation. Surcharge effect is the soil exactly above the footing or soil above the foundation level. That is the soil above the foundation level. Whatever the soil above the foundation level. Okay. So now, and NQ is equals to 1, N gamma is equals to 0. You have to remember this. NC value 5.14 when base of footing is rough, smooth. 5.7 when base of footing is rough. So NQ is equals to 1 and N gamma is equals to 0. NQ is equals to 1 and N gamma is equals to 0. So now let's recall our equation. Whatever the equation we have. Everywhere I use this as a parent equation. That's it. And I'll do modifications. Simply have a look. Remember N gamma 0, NQ 1. Then what about the QU? QU is nothing but CNC plus gamma D. CNC plus gamma D. If that is the case, then what is the net ultimate bearing capacity? What is the net ultimate bearing capacity? So ultimate bearing capacity CNC plus gamma D. Then what is the net ultimate bearing capacity? The net ultimate bearing capacity is nothing but ultimate minus self weight. Yes. So CNC plus gamma D. CNC plus gamma D minus gamma D. Both are going to be gets cancelled. So eventually, in the case of the clays, what is net ultimate bearing capacity? CNC. So cute, right? So the net ultimate bearing capacity is nothing but a CNC. If you observe in the case of the clays, from now onwards, if I want to design, okay, design condition, listen, design condition Q less than or equals to QS. What is QS? QNS plus gamma D. What is QNU? QNU by factor of safety plus gamma D. And what is QNU? CNC. What is QNU? CNC. So hope you understood. So in the case of the, eventually, in the case of the clayey soils, if I want to find out the net ultimate bearing capacity, I am removing the width effect, I am removing the surcharge effect. Can I give you one point over here after all this discussion? Right, if you see the ultimate bearing capacity, can you see any width effect? Can you see the any width effect? Ms. Ikra, why can't we take QS is equals to QU by factor of safety? Is that the question? In the ultimate bearing capacity, there is a self weight. Are you going to apply the factor of safety for the self weight? I told this point yesterday. I told you this point yesterday. Why we are not providing factor of safety for self weight is self weight is acting for a long period of time. And if there is a failure, the failure is due to external load, not due to the self weight. Yes? Okay. So now you tell me, in this equation, QU, CNC plus gamma D, is there any width effect? No. Can I say the point over here is ultimate bearing capacity of clay is independent on width of footing, which means you construct a footing, whether the width is going to be 1 meter or 3 meters or 5 meters, it doesn't matter. The ultimate bearing capacity of the clay footing does not depends on the width of the footing. No matter whatever the width of the footing, the ultimate bearing capacity is same. See, there was one of the previous gate question, 1 mark question. It was mentioned that as the ultimate bearing capacity of a clay soil under 1 meter by 1 meter square footing is 200 kilopascals. Listen to me. The ultimate bearing capacity of a clay soil under 1 meter by 1 meter square footing is 50 kilopascals. What would be the ultimate bearing capacity under a square footing of 3 meter by 3 meter? Tell me. Under 1 meter by 1 meter, the ultimate bearing capacity is 50. Under 3 meter by 3 meter, what would be the ultimate bearing capacity? No matter whatever, 200. Who said 200? Right? I'll kill you. I'll kill you. So as ultimate bearing capacity of clay is independent on width of footing, whether it is 1 meter or 3 meter or 5 meter, it doesn't matter. This is in the case of the clays. So now whenever I tell you clay, the net ultimate bearing capacity is simply CNC. Okay. So you may ask me now, sir, you said that in the shallow foundation, In the shallow foundation, there are different type of foundations. In spread footing, there is not only strip, right? There is isolated also. Isolated means for single column, single footing. Sir, for that, the shape would be changing now. What is the meaning of a strip footing? When the length of the footing is going to be much more than the width of the footing. But if you take isolated, in the case of the isolated, if it is square, length is equals to width. If it is a rectangle, length is more than width. And if it's circular, the B represents diameter. Okay. So, but Terzaghi has given only for strip footing. Clearly, Terzaghi has given only for strip footing. Now, let's see the alterations. If the type of footing or shape of footing is going to be changes. Different shapes of footings. First one in that circular footing. If it is a circular footing, then how you are going to find out the ultimate bearing capacity? If it is a circular footing, how you are going to find out the ultimate bearing capacity? So now again, whatever the primary equation I have, I take that one only. Whatever the primary equation I have, see, at the end you will get to know how many equations you need to remember. Only one equation. So now what I have done over here is I am just taking the whatever the parent equation I have. Now I will do modification. What is that modification, sir? This equation is valid for whom? Strip footing. If it is a circular footing, then the cohesion is going to be increases by 30%. Cohesion effect increases by 30%, 1.3. And whereas in the shape it is no more 0.5, it is going to be 0.3. As I already mentioned you, the 0.5 is for the strip footing. So these are all the empirical values. If it is a circular footing, then the cohesion intercept increases by 30% and shape factor is going to be 0.3. Okay. Now, second one, square footing. If it is a square footing, again, same. Let's take the same equation. You understand? You have to understand. Again, here also. So if I say square footing, then what is the change, sir? Again, in the case of the square footing also, the cohesion increases by 30%. The cohesion increases by 30%, whereas the shape is going to be 0.4. Okay. For circle, 0.3. For circle, 0.3. For square, 0.4. For strip, 0.5. Understood? So, now let's see the rectangle. In the case of the rectangle, how does it look like? Now, if the shape is going to be rectangle, for rectangle, how does the QU is going to be looks like? So how does the QU is going to be looks like? So here in this case, QU is 1 plus 0.3 B by L, same CNC. 1 plus 0.3 B by L CNC plus gamma D NQ plus or let me write this one separately because I cannot complete there. So what I do is if it is a rectangular footing, then what we can do? So for the rectangular footing, Again the same equation, but this time CNC, right? So now the cohesion effect increases by 1 plus 0.3 B by L CNC. 1 plus 0.3 B by L CNC plus gamma D and Q. See, if you observe carefully, in all the three shapes, gamma D and Q, gamma D and Q, gamma D and Q. I did not alter anything for the gamma D and Q. Why? Why I am not altering gamma D? Why I am not altering gamma D? Tell me. Why I am not altering gamma D? So if I can alter, see, where does the gamma D locates? The gamma D locates above the base of footing. Yes or no? And if the footing shape changes, whatever happened below the base of footing will change. But above the base of footing, whatever soil, it's just a surcharge. So it won't change. Okay. Now plus gamma D and Q plus 0.5 into 0.5 into 1 minus 0.2 B by L gamma B and gamma. Gamma B and gamma. Okay. So now, if you observe over here, if you keep B by L as 1, if I keep B by L as 1 ray, then 1 plus 0.3, 1.3. If I keep B by L as 1, 1 minus 0.2, 0.8 into 0.5. 0.8 into 0.5 means half of 0.8, which is 0.4. Which is 0.4. Okay. So in the case of the rectangle, the QU is equals to 1 plus 0.3 B by L CNC plus gamma D and Q plus 0.5 into 1 minus 0.2 B by L gamma B and gamma. So circular, square, and a rectangle. These are a small modifications. The main equation is whom? The main equation is Terzaghi for strip. If I say square, cohesion increases by 1.3 and shape factor 0.4. For circle, 0.3 shape factor, cohesion increases by 30%. There was one previous ESC question, means a gate question. Let me add that question for you. You see this question? This is a previous gate question, my dear. Now, the width of a square footing, and a dia of a circular footing. See, in this case, whatever the B is there, the B is nothing but diameter. The B is nothing but the diameter. So the width of a square footing and dia of the circular footing are equal. Okay. If both the footing are placed on surface of a sandy soil, what is the meaning of surface of sandy soil? What is the meaning of surface? So solution for this one, yet a surface, which means depth is equals to 0. Are Baba, if you are keeping the footing at depth at a ground level, is there any surcharge? No. At a surface, D is equals to 0. At surface, D is equals to 0. Okay. And as it is a soil, if the both the footings are placed on surface of sandy soil, so sandy soil, which means cohesion is going to be 0. At surface, depth is going to be 0. And sandy soil, cohesion is going to be 0. Then what is the ratio of ultimate bearing capacity of a circular footing to that of a square footing? You see, when D is equals to 0, no surcharge effect. And when C0, no cohesion effect. No surcharge effect and no cohesion effect. Okay. And now the other thing, the ratio of ultimate bearing capacity of, what is that? circle to square. Circle to square. So whenever I asked you to, you don't remember the total equation. You know, cohesion effect gone, surcharge effect gone. What is remaining? So this is 0.3 gamma B and gamma, and 0.4 gamma B and gamma. Anyways, whatever the width of the square footing and dia of the circular footing, both are same, right? So this gets cancelled. Then answer is going to be 3/4. So this is GATE 2018 set 1 mark question, my dear. I mean, based upon these concepts, now you can see a lot of questions has been asked. So within a meantime, we'll start solving all those things. Don't worry. Sir, when we take NQ as NQ minus 1, Mr. Ramchandra Ketawat. So normally we will not provide footing and surface. No, normally we don't provide, but this is for the understanding purpose only. Okay. So now let's see this. And okay, fine. You see, first whatever the equation given by the Terzaghi is for strip footing. Okay. And what I have done is I modified the equation for various shapes. Okay. And what happens if it is a clay soil? Okay, I have shown you. Now, one more thing. Terzaghi said this theory for whom? Terzaghi said this theory for whom? General shear failure. But you know that general shear failure and local shear failure can be seen in the shallow foundations. But what is the biggest difference between the general shear failure and local shear failure? This is a full shearing, but this is a partial shearing. The meaning of full shearing is a full cohesion and full friction is going to be mobilized. The meaning of partial is whatever the developed cohesion and friction are not actual values, Okay. So now if you observe, yeah. So for local shear failure, which means LSF. So when phi value is less than 28 degrees. So whenever in the given question, sometimes they will mention you as local shear failure. Else, if you see the phi value less than 28 degrees, you have to take it as yeah. So we have to take it as a phi less than 28 degrees. Okay. So now in this case, what to do? Same equation. I'm not going to change the equation. You see how many times I'm using the same equation. But sir, then what is the difference, sir? The simple difference, sir. The simple difference is going to be here. The C is no more C. The C becomes CM. And phi is also going to be changes, right? As you know, in the case of local shear failure, the shear is going to be happens locally. It's a partial shear. Cohesion will not mobilize fully. CM will not be C. Friction will not be mobilized fully. Phi m is not is equals to phi. And you know that this NC, NQ, N gamma are bearing capacity factors which depends upon whom? Phi. Which depends upon whom? Phi. If phi changes, then these are also going to be changes, na? NC dash, NQ dash, N gamma dash. So what is this NC dash, NQ dash, N gamma dash? NC dash, NQ dash, N gamma dash dependent on mobilized friction phi m. So how to find out this phi m and Cm? So that Cm is equals to 2/3 of C and tan phi m is equals to 2/3 of tan phi. So this is how you are going to find out the simple modifications. Here it's all about you need to understand the modification. So if it is a local shear failure, you know that the shearing happens locally or partially. So the strength is not mobilized fully. Cohesion will not mobilize fully. How much it will mobilize? 2/3 only. 2/3 of actual. 2/3 of actual. Okay. So now this is the factor of Yeah. So that's about the local shape failure. Okay. Sir, we consider the different type of shapes. Yes. We consider different shapes. Yes. We consider different soils. Yes. We consider different failures. Now, one thing is left over, which is nothing but Terzagh's main concept. Terzaghi principle is based on effective stress armor. And when the effective stress comes into existence, when there is a water table. Now let's see the effect of water table. Effect of water table. What is the effect of water table? Okay. By using stylus chart, we don't find mobilized cohesion, sir. How come you find out? You don't do that. That is for the stability of slopes. This is for stability of foundations. Okay. So effect of water table. Now let's take footing. Okay. So ground level. There is a ground level. And this is the base of the footing. So now, if you observe, you know the effect of the entire load I can take up to the width up to the width. See, if B is the width of the foundation, then the shearing will happen up to that depth, which is equal to the width B. And whatever the depth of foundation, let's take it as D. So now, listen to me carefully. The Terzaghi has given his entire analysis in a depth of D plus B only. Yes or no? And if the water table is well below this, so number one, let's say the water table is located well below the base of foundation. Come on, tell me. Our effect is here it is gamma D, here it is gamma B. So we are not considering anything regarding to the means below this dotted line. Yes or no? So step number one, if the water table is located well below the base of footing, is there any change in the equation? Come on, tell me. Is there any change in the equation? A water table below well below base of footing. So if I say the water table is going to be well below the base of footing, is there any change? Is there any change in the equation? No change in the equation. And I'm going to take the same equation. If it is a square, if it is a strip footing, so let me assume everything is for the strip footing. Okay. CNC plus gamma D and Q plus 0.5 gamma B and gamma. See, everything I'm explaining on strip footing. And if I say square, you have to add 1.3 for cohesion and 0.4 for the shape. Understood or not? So even if it is a square footing and if there is a water table, you have to write as 1.3 CNC. Whatever the discussion I am making is for strip. If it is a square, you know where to change. Okay. Now let's see how strip footing possible for circular footing. Okay, fine. Now let's see if the water table is at the base of the footing. Come on, tell me. What will be happen, everybody? If the water table rises to the base of footing, are below the base of footing, soil is under submergence. Yes or no? Above the base of footing, there is no submergence. So above the footing, surcharge effect, no effect. and below the footing width effect complete under submergence. So now let's see. B, water table rises to base of footing. If water table rises to base of footing, okay. So now what is the change you are going to see? What is the change you are going to see in this equation? What change you are going to observe? Everybody, what change you are going to observe? There is only change in the width. Simply the gamma becomes gamma dash. Gamma becomes gamma dash. Why? Soil below the base of footing is under submergence. Now, if you have understood all these things, now if that water table rises up to the ground level, then what will happen? Now see, water table is yet ground level. And Baba, if the water table is at ground level, the complete soil is under submergence, right? The complete soil is under submergence. So when the complete soil is under submergence, now what is the equation? What is the equation? Same equation. What is the change you are going to see here is, as the soil, entire soil is under submergence, then here this is also gamma dash, and here this is also gamma dash. Hope you got it. Understood or not? What is changing? Anything is changing here? You observe, understand what the modification I'm doing. Instead of remembering the whole formula, you just observe where I'm changing. If the water table is well below the base of footing, no change in the unit weight. But if the water table rises to the ground level, as entire soil is under submergence, gamma becomes gamma dash in surcharge effect and width effect. So now I'll give you one note point. What if the soil is a cohesionless soil? Listen to me carefully. If the soil is cohesionless soil, soil is cohesionless soil. When the soil is cohesionless soil, the cohesion is going to be gone. Yes, the cohesion is going to be gone. Now you observe in cohesionless soil, when the water table rises from well below the base of footing to the base of footing, when the water table rises from well below the base of footing to the base of footing, you know that when water table rises, effective stress decreases or increases? When water table rises, effective stress increases or decreases? Obviously, it is going to be decreases. So now, in the case of the cohesionless soil, if I take, when the water table rises from A to C, so I'm taking this one as C, right? Yeah. So this is C. From A to C, when the water table rises from A to C, then if it is a cohesionless soil, my dear, or a cohesionless soil C0, then can I take gamma common? Can I take gamma common? Yes or no? Can I take gamma common? Yes. And now, after the, when the water table rises over here, C0, I can take gamma dash common? Yes. Which means, in the case of the cohesionless soil, when the water table rises from well below the base of footing to the ground level, gamma is changing to gamma dash. Gamma is changing to gamma dash. When gamma is changing to gamma dash, is it reducing or increasing? Obviously, gamma dash is very, very less, right? Gamma is changing to gamma dash, which is almost half. I'm not saying exactly half, it's almost half. So when the water table rises from well below the base of footing to the ground level, well below the base of footing to the ground level, in cohesionless soil, the ultimate bearing capacity reduces by almost 50%. In cohesionless soils, when water table rises from well below the base of footing. Okay. In erosionless soil, when water table rises from well below the base of footing to ground level, well below the base of footing to ground level, the ultimate bearing capacity reduces by almost 50%. Why, sir? Because gamma is changing to gamma dash. Gamma is reducing to gamma dash. The gamma dash is almost 50% of the gamma. So whatever the gamma is going to be reducing to gamma dash. Okay. So water table well below the base of footing. Now I hope you understood. Sir, you were saying well below yet a footing and yet the ground level. Can you tell us what happens if the water table is somewhere below? Now have a look. Let's say if the water table is somewhere over here. Let's say if the water table is somewhere over here, somewhere below the base of footing, and let me say that somewhere below the base of footing as somewhere below the footing, and let me say whatever the somewhere below the footing, the depth somewhere below the footing, let's take it as ZW2. ZW2. So now A, B, C, D. So water table is somewhere below the base of footing. Water table is somewhere below the base of footing, not well below the base of footing. Water table is somewhere below the base of footing. Okay. So now, whatever the D, when water table locates at a depth of ZW2 below footing level. So can you tell me what would be the ultimate bearing capacity? Can you tell me what would be the ultimate bearing capacity? You please tell me, Are Baba, if this is the water, then the entire surcharge is not under submergence. And in the width up to ZW2, there is no submergence. But in the B minus ZW2, whatever this width is, this depth is B minus ZW2, that is under submergence, which means now if I do write the equation, so if you can understand, I don't need to worry about the surcharge effect because there is no change in the surcharge effect because the water table is below the foundation. But what about the width effect? Up to ZW2 gamma, below ZW2, below water table gamma dash, which means 0.5 into gamma ZW2 plus gamma dash gamma ZW2 plus gamma dash into B minus ZW2 into N gamma. Can I write like this? Into N gamma. Okay. So whatever, this is nothing but N gamma. I hope you understood. Do I need to remember all these things? What I am saying you is below water table, just simply gamma dash. You below water table, just simply gamma dash. That's it. And now similarly, can you explain me what happens if this water table is somewhere below the base of footing? Sorry, somewhere below the ground level and above the footing base. Now let's say whatever this depth is ZW1. Now come on, tell me. Are Baba, if the water table is here, entire soil below the base of footing is under submergence. So below footing is under submergence, and in the depth effect up to ZW1 there is no submergence. Now what should be the equation? Water table at a depth of ZW1 below ground level and above footing. So now what should be the equation? Come on, tell me. The equation is QU is equals to CNC. That's it. Fine. But what about gamma D in surcharge effect? Above water table gamma ZW1. Above water table gamma ZW1 plus gamma dash into D minus ZW1 into NQ. Yes, plus as it is completely submerged, 0.5 gamma dash B N gamma. You tell me, do you really need to remember? You tell me, do you really need to remember? I'm asking you people, do you really need to remember all these formulas, whatever the written, whatever the discussion I have done? No. If you have understood, then you don't need to. What you need to understand here is below water table, wherever there is a water table, below water table only submergence, above water table gamma, that's it. And for this explanation, there is one more method known as approximate method that is based upon some factors. That is ultimate bearing capacity based upon some water table reduction factors. See, this is exact analysis. Whatever the discussion I have given, this is exact analysis, A, B, C, D, E. Now there is one more methodology known as approximate method. This approximate method is based on whatever the approximate method. This approximate method is based on water table reduction factors. Again, same equation, but what change happen here is just we will include a factor, water table correction factor, or W1 or W2. So what is this RW1 and RW2? So that's the reason why I represent between ground level to base of footing, I represent ZW1, and below base of footing, I represent ZW2. So now let's see how many of you will say. I'll write down this RW1 and RW2. This RW1 and RW2 are water table reduction factors. So due to water table, you know, ultimate bearing capacity decreases, right? Okay. So what is mean by ZW1? Now first, what is RW1? RW1 is nothing but 0.5 into 1 plus ZW1 by D. Sir, what is the meaning of this, sir? You just go back. Are Papa, what is the range of ZW1? Can you please tell me? What is the range of ZW1? The ZW1 is below the ground level. Means if the water table is at ground level, ZW1. Give me a minute, please. So yes, now if you observe here, so now if you see in this case the ZW1, what is the range of the ZW1? If the water table is at ground level, if the water table is at ground level, the ZW1 is 0. So ZW1 can be greater than or equal to 0. Now, if the water table is at the base of footing, what is ZW1? Come on, tell me. What is ZW1? Come on, tell me here. If the water table is at a footing base, then this ZW1 is nothing but D. So the range of the ZW1 is 0 less than or equals to ZW1 less than or equals to D. 0 less than or equals to ZW1 less than or equals to D. Okay. So that is the range of the ZW1. Similarly, can you please tell me what is what about the ZW2? What about the ZW2? The ZW2, you see the range of the ZW2. What is the range of ZW2 here? See, ZW2 is, that is a depth of water table below the base of footing. So if the water table is at footing level 0, and if the water table is well below, the maximum is going to be B. That's it. I will write the same ranges here also. Similarly, what about the RW2? The RW2 means water table correction factor, which is nothing but 1 plus the water table location varies from ZW to the B, where 0 less than or equals to ZW1 less than or equals to so what is the range of the G? What is the range of the ZW1? Come on, tell me. The range of the ZW1 is 0 less than or equals to ZW1 less than or equals to D. If that is the case, then what is the water table correction factor? Water table, what is the correction factor? So come on, you tell me please, in this case, if you have understood. So then what is RW1? What is the water table correction factor? Remember, when ZW1 is 0, when ZW1 is 0, anything 0 by anything 0, 1 plus. So then the water table correction factor is 0.5 less than or equals to RW1. Now, when the ZW1 is going to be D, when the ZW1 is going to be D by D, 1 plus 1, 2, 2 into 0.5, 1. Hope you understood. Hope you understood. Yes or no? So this represents when water table lies between ground level and footing, then you are going to say this one, yes or no. And if the water table is going to be locates okay, say instead of I write this one, I'll give you again separately. Why? Because you have to include the RW2 also, right? So yeah. Similarly, can you please tell me what happens if this is a ZW2? So again, you know that the ZW2 is having a range of ZW2 to B. Now, what should be the RW2 here? Give me a minute. What should be the RW2 here? Here also, what is RW2? RW2, when you keep ZW2 is 0, when you keep ZW2 0, when the ZW2 is 0, when the water level is at the footing level. Don't worry, I'll write every point. So now when ZW2 is 0, what is RW2? 0.5 less than or equals to RW2 is less than or equals to 1. So just I want to know what is the range of ZW1 and ZW2 so that I can get to know what is water table correction factor. What is the minimum value of water table correction factor? 0.5. What is the maximum value of water table correction factor? 1. Now let's see. Case A. When water table is well below the base of footing, when water table is well below the base of footing. When water table is well below the base of footing, then you please tell me what is ZW1? When the water table is well below the base of footing, then what is ZW1? Come on, tell me. What is the ZW1? Papa, water table is very well below the base of footing. Here, what is ZW1? Do you think ZW1 is D plus B? No. What is the maximum depth of ZW1? The maximum depth of ZW1 is D only. Yes. So what is ZW1? D. What is ZW1? It is going to be D. Okay. And what is ZW2? What is ZW2? The ZW2 is also going to be B. So the maximum value of ZW1. So when the water table is here, the maximum value of ZW1 is D only, and the maximum value of ZW2 is B. So now you tell me here, when ZW1 is equals to D, what is RW1? RW1 is equals to 1. RW2 is equals to 1. Yes or no? Now if you substitute in the equation, what should be the value? This is how the ultimate bearing capacity looks like. Yes or no? Yes or no? So CNC plus gamma D NQ plus 0.5 gamma B and gamma. I hope you understood. Similarly, now if you have understood these factors, now can you please tell me what happens when water table is at ground level? When water table is at ground level, can you please tell me what is ZW1 now? What is ZW1 and what is ZW2? What is ZW1 and what is ZW2? Come on, I want you answers. Array, both are 0, na? When the water table is at the ground level, ZW1 is 0. Anyways, water table is above footing, so ZW2 is also going to be 0. Then what about RW1? When ZW1 is equals to 0, if you keep that water table reduction factor, ZW1 0, RW1 0.5. So that's why I have given you the ranges. And what about RW2? That's also going to be 0.5. Okay. So with this, can you tell me if I give you anywhere, can't you find out the water table correction factor or not? But sir, in examination, which method I should go for, sir? In examination, you have to go for the exact method only. Until or unless they mention use a water table reduction factor, do not use the approximation method. You always go with the gamma dash below water table. If I do mention the approximation method, then only you apply RW1 and RW2. So now RW1 and RW2 are going to be 0.5. Now if I do write the ultimate bearing capacity, now in this ultimate bearing capacity, I have two factors, right? So RW1 and RW2. So this is going to be 0.5 into this value, and this is going to be 0.5. Yes or no? Now, can you please tell me from this itself, you can say if it is a cohesionless soil, if cohesionless soil, if C is equals to 0, then what is QU? Gamma D and Q plus 0.5 gamma B and gamma. Yes, I'll show you whatever the conclusion I have made over here. I'll represent that conclusion also here. So if C is equals to 0, what is the ultimate bearing capacity here? Which is, I can take it out the 0.5 common. Yes or no? I can take it out the 0.5 common. Gamma D and Q plus 0.5 gamma B and gamma. Hope you got this. Alright, this is gamma D and Q plus 0.5 gamma B and gamma. This is 0.5 into gamma D and Q plus 0.5 gamma B and gamma. Understood or not? So this is water table correction factors. So all these analysis I have given for the sake of better understanding only. You don't require too much. If I would have asked you, sir, at a particular depth, I want to find out the water table correction factor, can't you find out? One values RW1 and ZW1 should use below ground level, above footing. And RW2, ZW2 should use below footing and above, well below the base of footing. Hope you understood. I know that's the reason why before you ask me, sir, whether we need to change the gamma to gamma dash. No, na. That's what the purpose of the water table reduction, right? What is the meaning of 0.5 gamma? That represents gamma dash. So you don't change anything. You just apply. In the case of approximation method, you don't change any gamma. You just apply the RW1 and RW2. That is the reason why we call it as approximation. Keep that in your mind. Okay. Yes. So hope you understood all these things. Yes or no? So C dash Q nahi hua sir. That is the see. After all the entire 13 chapters, some people are need to be understand array C dash or phi dash, CU or phi U. If they do mention it's a drained, you use C dash phi dash. If they do mention it is undrained, you use CU phi U. If they don't mention anything, don't bother at all. Okay. So now that's it. This is A and this is B. Okay. And now conclusions, note point. See, so far and so good, we have discussed about a lot of things. Let me give you how many equations I have used so far. How many equations I have used so far? Only one equation. In the examination, while you are going to solve, you have to keep one thing in your mind. What type of footing they are giving? Is it square, rectangle, or strip? If it is a strip, QU, CNC plus gamma D NQ plus 0.5 gamma B and gamma. Okay. If it is a square, you know the cohesion increases by 30% and shape factor 0.4. If it is circular, 1.3 and 0.3. But these are not given by whom? Terzaghi, right? Terzaghi gave only one equation for strip footing, but we have done the modification. So this is a limitation from the Terzaghi. Terzaghi. If you would have given some factor, just like a water table correction factor RW1, if you would have given some factor, just like bearing capacity factor, I don't need to remember too many formulas for square, rectangle, circle. So first limitation of Terzaghi is he did not take in care the account of various footing shapes. Shape factor has not included. Number one. Number two, Terzaghi says this theory only for the general shear failure, which means it is only for shallow foundation, which means he did not account at the depth. This theory is not suitable for the pile foundations or deep foundations. So I cannot use it. So one thing for sure, listen to me carefully, one thing for sure, Terzaghi did not account the different shapes. He took only strip. He has this analysis. This is entire analysis for strip footing only. This entire analysis he has given for strip footing only. But we managed it somehow and we have written these equations. Okay. So shape has not considered. Shape has not considered. Yeah. Shape has not considered. Okay. Number two. It is suitable only for depth, shallow foundations. So he did not consider the full depth. He did not consider whatever the depth it is, whether it is shallow or deep, he did not consider. He considered only shallow foundations. Depth factor also not considered. Number three. Do you think always the load is going to be concentric? Don't you think the footings can be eccentric also? Yes, it can be eccentric too. Do you think always the loading or footing is going to be concentric? Concentric means center. So sometimes the load can be eccentric too. So he did not take care of the eccentricity. He didn't even bother about the eccentricity. Okay. And one more thing. So if you observe here, he did not take care of the inclination. See, do you think always load is going to be vertical load? In the case of hilly areas, there is some inclined load also, or there is some lateral load also. He did not take in care that those. So now what are the various limitations in the case of the Terzaghi's theory is limitations. The limitations for various theories. Number one, so not suitable for deep foundations. Did not accounted for footings other than strip footing. Okay. Inclination of load and depth factor is not considered. So these are all the various limitations of the Terzaghi's theory. He provided for water table, but the biggest limitation is it is suitable only for shallow foundations. And there comes next theories, which are nothing but Skempton's theory. Sir, can we use this theory for stratified soil? Yes, you can use. There is no problem with the stratified soil. So now the second theory is Skempton's theory. What is this Skempton's theory, sir? Skempton's theory says that this theory is suitable for undrained cohesion only. This theory is suitable for undrained cohesion only. Suitable for undrained cohesion. And this can be applicable in both shallow and deep foundations. Applicable for shallow and deep foundations. Okay, so what is the advantage? The biggest advantage of Skempton over the Terzaghi is Skempton said only for shallow, means Terzaghi said only for shallow, but Skempton said that you can use it for anything, but this theory is only for the undrained clays. Undrained clays. Eccentricity also, okay. Inclination of load, depth factor, and eccentricity. And eccentricity is not considered. Okay. So according to Skempton, what he said is, Are Baba, you know, for the clay, what is net ultimate bearing capacity? For the clay, what is net ultimate bearing capacity? The net ultimate bearing capacity is CNC. Skempton also used the same thing. Array, the net ultimate bearing capacity is CNC only. I don't take care anything. Okay. Now, what is the difference? NC is 5.14 according to Prandtl. NC is 5.7 according to the Terzaghi. And now, in the case of the Skempton, NC is not going to be constant. There comes the difference because it should be applicable for both shallow and deep, right? So NC is equals to 5 into 1 plus 0.2 D by B. Because for shallow or deep, it has a different width, different depth. So I considered over here for different depth and width, the D by B value will changes, NC value will changes. And this is for strip footing. So strip footing. This is for strip footing. And what about other footings? NC is equals to 5 into 1 plus 0.2 D by B into 1 plus 0.2 B by L. Yeah, if you ask me to remember this, yes, you have to. For Terzaghi, I made too simple. So what is the equation? Where the changes will come. But for here, you have to remember this. The NC is equals to 5 into 1 plus 0.2 D by B into 1 plus 0.2 B by L. Okay, this is for rectangular footing. And if you keep B by L as 1, if you keep B by L as 1, you just say what happens if you keep B by L as 1. What about surcharge effect? You don't require the surcharge effect. Already we are taking the surcharge effect, right? Arey Baba, you asked me a question, very good question. One of our student is asking, sir, what if there is a surcharge, sir? Sir, already whatever the soil above the footing is also surcharge, sir. For example, you have to apply 50 of surcharge, then it is going to be gamma D plus 50. That's going to be surcharge. So whatever the soil or load above the footing, you have to take it as surcharge. So rectangle. Now, if it is a rectangle, means if it is a square, then what is going to be happen? If it is a square, then what is going to be happen? Square means B by L is equals to 1, 1 plus 0.2, 1.2. 1.2 into 6 means 1.2 into 5, it is going to be 6. So then 6 into 1 plus 0.2 B by B. So this B by L is taking a shape accountants. Shape accountants. For strip, I don't need to worry about shape because L is greater than B. But for rectangle, shape is different. Square, shape is different. Dimensions are different. So shape factor was accounted. Depth also accounted. So depth you have taken care and the shape also you have taken care. But still, this is lack of inclination. Still, it is a lack of eccentricity. Okay. So this is for square footing. You see, now I am not taking too many formulas. I am taking only one formula, very cute formula, sweet formula, which is known as net ultimate bearing capacity is CNC. And in that NC, we are changing everything. So in the case of Skempton's, he has taken depth account, he has taken shape account, but he did not accounted the inclination. And by taking all this into the factors, now there comes one more theory known as Meyerhoff's theory. In the case of the Meyerhoff theory, inclination of load also considered. Here you don't need to remember this one also. Why? I'll tell you. What is the equation? What is our equation? QU, so far and so good. Whatever the equation you remember, QU is nothing but CNC plus gamma D NQ plus 0.5 plus 0.5 gamma B and gamma. This is our main equation. Yes. Now, Meyerhoff says that at Terzaghi, you did not take in care all those things. To fall to Skempton, you have taken a lot of things and you give big formulas. I don't do all these things. What I'll do is simply how you are giving the bearing capacity factors NC, NQ, and gamma. Similarly, for shape, for depth, for inclination, also I give you the factors. Sir, on what basis these factors depends on is nothing but B by L ratio and load ratio. The Meyerhoff has given some tables for the shape factor, for depth factor, for inclination factor. So he has mentioned that now NC into, for taking care of S shape factor, SC, SQ, S gamma. For taking care of depth, DC, DQ, D gamma. For taking care of inclination, IC, IQ, I gamma, O gamma. Okay, na? Now, how many factors it is there? Here, S represents shape factor. You tell me, do you want to remember this equation also? D represents depth factor. And I represents inclination factor. Okay, so whenever they mention the factors SC, DC, IC, SQ, DQ, IQ, you just have to go blindly. The theory is Meyerhof. Apart from this, there are other miscellaneous theories like Wesik's theory, Prandtl's theory, IS code method, Kozlov's method, Ting's equation. See, bearing capacity is not a closed-ended topic. It's an open-ended topic. You see, there are many formulas in the textbook, but you don't require for both gate and ESC, for both the gate and ESC. So whatever the equations that we required is Terzaghi. 99% of the questions you expect from Terzaghi. Terzaghi. If they mention Skempton, that is suitable only for clays. If they would have given the factors of a shape, depth, inclination in the question, you go for the Meyerhof. You go for the Meyerhof. And apart from, sir, if there is a water table, you know that. If there is a water table, what to do? Below water table, gamma dash. Sir, which of these methods we actually use in reality? Sir, here we are taking consider of y 0 point. Very good question again. Now let me go back once again. You see, this is a basic equation I told you. And how I attain these values are 0.4. The 0.4 is nothing but 0.5 into 0.8. The 0.3 is nothing but 0.5 into 0.6. You observe the shape factor is 0.6 here. The shape factor is 0.8 here. So 0.5 into some factor is 0.3. 0.5 into some factor is 0.4. Understood or not? Similarly, you observe here also 0.5 into this factor is nothing but the rectangle. So now instead of using this all these things, I'm giving you finally one value. Okay. Now, so this is about the Meyerhoff's theory, Skempton's theory, and Meyerhoff's theory. And still one thing is left over. That is what? Eccentrically load. If we complete eccentrically loaded, analytical things will be completed in this chapter. So now let's see what is that eccentrically load. So if I would have given eccentrically load, what happened? So I am dividing every topic as a schema. And once you understand this, then you can digest it easily. Okay. Now, so far and so good. Whatever the discussion we made, whether it is the Rankines, whether it is a Terzaghi, whether it is a Skempton, whether it is Meyerhof, everybody took the load as a concentrated load. But what if the load is not concentrated? So now, if you observe here, yeah, eccentrical load. So what if say some textbook says in circular footing it is 1 point? No, you don't go for that. You just use 1.3 only. Which of these methods we actually use in reality? It depends, my dear. It depends upon the values that you are going to take. But generally we consider Terzaghi only. what is second term? Gamma d and gamma. Gamma d and gamma d and q is same, right? There is no 0.5 or something like. Okay, fine. So now let's see the next term. Eccentrically loaded footings. Eccentrically loaded footings. Okay. So in the case of the eccentrically loaded footing, what if the footing is not concentrated? So let's take a footing. So listen to me this. If this is a footing base, and let's say the footing is not at center. I mean the column is not at a center. So this is the ground level. This is a ground level. Okay. So in the case of the ground level, now in the case of the ground level, so if you observe here, whatever the load that I am applying is Q, and the line of action whatever the line of action. So from the center, let's take this is a center, and that is nothing but a center. From the center, in the axis where I am seeing the width axis, in the width axis, let's take whatever this value is, Ex. Whatever the eccentricity, eccentricity means from the center only, right? Ex. If this is Ex, then what about this value, my dear? What about this value? Array, total width is b by 2, na? This is center. Okay. So from the center, the load is acting at a Ex. And what about this value? This is nothing but b by 2 minus Ex. Can I say like that? Yes. Yes. Questions are also framed from that's like only. Okay, so this is nothing but b by 2 minus Ex. Now, this is section view, right? This is a section view or elevation, you can say. Now, let me take a plan view. Of the same footing. This is a plan view of the same footing, whose width is going to be b and whose length is going to be L. Because whatever the discussion I am making is with respect to B and L only. Yes. Now, observe. So as it is a center line, so this is center line. Okay. And here also it is going to be the center line. Generally, if the load is a concentric, then it should act over here. Yes or no? Generally, if the load is at concentric, it should act somewhere over here. Okay. So now what I am showing you is an eccentric load. That eccentric load, what you are seeing in one dimension, which is nothing but B. Now, listen to me carefully. If the load is at a center, the load should act over here like this. The load should act here. But now I am not taking a load as a concentric. Eccentric means it can be anywhere. Yes. So now this is the point of load. And now let's say the point of that load is acting here. So this is how, I mean, here the load is acting. Now let me consider. See, the point can be here, or the point can be here, the point can be here. The load can be here or here or here. So with the water, eccentricity Ex. So let me take the load is acting somewhere over here. Let me take the load is acting somewhere over here. In that direction, whatever the eccentricity, this is nothing but Ex. Can I see like that? Yes or no? Now you tell me, does the load has a one-way eccentricity or two-way eccentricity? From the center line in X direction, with direction Ex, and from the center line in Y direction, it is going to be Ey. So is it a one-way eccentricity or two-way eccentricity? Is it a one-way eccentricity or two-way eccentricity? It's a two-way eccentricity. What if I say, the point is only here? What if I say the point was only here? Is it a one-way eccentricity or two-way eccentricity here? Is it one way or two-way? Now this is only one way because the point lies on center line, but having some distance from the means in the x-axis. So now based upon one way or two way, if it is a two way, two eccentricities Ex and Ey. Now you please observe here, this is two-way eccentricity. Fine. I hope I was able to make you to understand what is this Ex and Ey. Okay. Come on, Baba. You know this value. This value is nothing but same b by 2 minus Ex. And you need to know this value also, right? What about this value? What about this value? This value is nothing but L by 2 minus Ey. Okay. 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 Now you see, now after all this discussion, whatever the theories that has explained me, whether it is a Rankines or Terzaghi or Skemptons or Meyerhoff, everybody assumed the load is acting at center, concentrated load. So I don't have any theory which represents the eccentrically loaded. So I have two options now. One option is either we should create a new theory for eccentrically loaded, or we have to use the existing theories. So if we want to introduce new theory, you have to do research, but you are not doing research. You are going to get examination. So don't bother about that. The second option is much better. What is that second option, sir? Concentrated load. But sir, here it is eccentric, na? Then what I can do, na? I will convert the eccentricity load into equivalent concentrated load. So to apply the existing theories, in order to find out the ultimate bearing capacity, I am going to convert this eccentrically loaded as equivalent concentrated load. Sir, I say, sir. How it is going to be possible, sir? Simple. What I'll do is, I don't take the total area now. I will just take the area where this load is going to be act as a center. Where this load is going to be act as a center. Now you see how I'm going to do that. So you know, whatever this is nothing but total area. Yes. That what is the total area? The total area. This is nothing but B and this is nothing but L. So whatever the point is existing somewhere over here. The point is existing somewhere over here. Yes or no? So now, if I want to make sure this is a concentrated point load, means equivalent concentrated point load. Now what I'm going to do is, instead of taking the total area, I will take the area like this. Now you observe, this is the load that I am going to take. Now this point is nothing but a concentrated equivalent concentrated load. Now what is the dimensions here? What is the dimensions here? Now this dimension is B dash and L dash. So the eccentrically loaded area has been converted from we converted it to equivalent concentrated load by reducing the base area to B dash and L dash. So can you please tell me what is B dash and L dash here? Can you please tell me what is B dash and L dash? Come on, you know it, right? Can you please tell me what is B dash and L dash? I want you to say. Yes. So what is B dash? B dash is nothing but 2 times of B by 2 minus EX, which is nothing but B minus 2EX. Can I write like this? B minus 2EX. Yes or no? And what is L dash? L dash is nothing but 2 times of L by 2 minus EY, and L dash is equals to L minus 2EY. L minus 2EY. So B dash and L dash. B dash and L dash. Okay. So what we have done is we have reduced the base area to B dash to L dash. Now, eccentrically loaded footing is converted to or is transformed to equivalent concentrated load footing by reducing base from the area B by L to B dash by L dash. Okay. And what about the ultimate bearing capacity now? Now the ultimate bearing capacity is CNC. What we know, I can write that. What do we know? Everything the same equation we take. Now we take the same equation. But what is the change? What is the change you are going to see? The change we are going to see here is simply B dash. Okay. The same equation, but eccentricity, the B becomes B dash. Sir, where do you use L, sir? When you are going to find out the loaded area, na, QU, load by area. In that area, you have to reduce this to B dash to L dash. Means B dash by L dash. So hope you understood now. If it is a one-way eccentricity, tell me. For example, if the load is acting at one-way eccentricity now, for one-way eccentricity, EX only. So for the one-way eccentricity, what would be there? So again, you take this point. Now you take the center. So this is a center. Yes. Now let's say the load is acting over here with a one-way eccentricity only. With one-way eccentricity only. Okay. So now what we do? Come on, now what we do? If it is a one-way eccentricity, I don't need to modify the length direction. Did I? Means or do I? No, I don't need to. So what I do is I have to make sure this point as a center. I have to make sure this point as a center. So if I want to make sure this point as a center, now please observe what I'll do is I'll just make up the same distance on the other side. Now this is B dash and this is L dash is equals to L only. So now if I make sure this point as a center, so here B dash is nothing but B minus 2EX. But what about L dash? L dash is simply L only. So based upon the eccentricity, you have to define. And once you know that, so what is B dash? B minus 2X. If you ask me, what I'll do now? Whatever this value, if I want to make this center, the other width also should be same. I want to make this point as center so that if this value is B by 2 minus EX, the other value also B by 2 minus EX. The total width is 2 times of B by 2 minus EX. Hope you understood. Sir, if what is the meaning of L? Are always B represents shortest dimension, L represents longest dimension. If I say the B is always a shortest dimension, L is always longest dimension. So never ever think that L dash is going to be less than B dash. So with this, we completed. Sir, where we use L, sir? In the area, see, load is there, na? Whatever the ultimate load means some ultimate load by area would be there, right? There you are going to find out. Wait for the questions. There I'll explain you. Don't worry about that. Don't worry about that. I'll explain you. So this is the analysis. How to determine the ultimate load carrying capacity, ultimate bearing capacity. Once you know the ultimate bearing capacity, you very well know that how to find out the or how to design. So let's have a break now. So meanwhile, you just have a look and revise these topics. So let's have a break. It's now 7:03. So we will take some 15 minutes break and we'll come back by 7:20. 7:20, we'll solve problems based on this. Then you will get to know. Okay. Okay, so now let's come to the questions. Okay, so let's start solving the questions. You see the question number one first. See, I already told you while we are solving a question, we have to be very careful about what type of footing they are giving, about what type of soil they are giving. So we need to be very careful about that. You see, in this question, it is mentioned a footing 3 meter square. So a footing 3 meter square. A footing 3 meter square, which is nothing but a square footing of 3 meters. Square footing 3 by 3 meters. Okay. Carries a gross pressure of 350 kilonewton per meter square. Okay. So there is a square footing which carries a gross pressure. What is the meaning of gross pressure? Vaibhav Vasudhani, is this chapter over? Yes, it is over. You can pack up. Give a minute, please. The square footing carries a gross pressure of 350. So what is the gross pressure? The gross pressure acting over here is 350 kilopascals. What is mean by gross pressure? The gross pressure means the total pressure acting on the footing at the base of footing. At a depth of, what is the depth of foundation? 1.2 meters. The saturated unit weight of the sand, gamma sat, is 20 kilonewton per meter cube. And whatever the unit weight of soil above the water table is 17 kilonewton per meter cube. So we have mentioned the shear strength parameters, which are C is equals to 0. And for 5 30 degrees, as I already mentioned you, they will be mentioned the NC, NQ, N gamma. Anyways, when C is equals to 0, the cohesion effect is gone. So I don't need to worry about the cohesion effect, in fact. So whatever the NQ is 22. Don't ask me why they are not giving NC, sir. If they do give NC also, that's of no use. And N gamma is 20. So what I am asking you is determine the factor of safety with respect to the shear failure. So what is the factor of safety? This is what we are going to see. First thing first, I told you the design condition, right? I told you the design condition. So what is the meaning of design, sir? What is the meaning of design? See, if you want to design the width of the footing, if you want to design the depth of the footing, if you want to know, or if you want to design what is the safe load acting on the footing, and if you want to know the factor of safety, these are all the design conditions. So when you're designing, you need to know what is the width of foundation, what is the depth at which you are going to go for the foundation, what is the load that the soil can take safely, and with what factor of safety you are going to apply that load. Okay, so this is a design criteria. First, let's draw the figure. First, let's draw the figure as it is a Shubhaibo, you are being in the class, right? You're being in the class, and you are being in the class, and you know that the chapter is going on. Then how come you think that the chapter is over? So now, let's take this is the footing. Yeah, and you know that this is a ground level. So you know the ground level means whatever the footing is located at a depth of the footing is located at a depth of 1.2 meters. The footing is located at a depth of 1.2 meters. And what is the width of the footing we have mentioned? So the width of the footing is 3 meters, right? Is it a 3 meters? So width of the footing is going to be 3 meters. And whatever the analysis we are going to do is the depth up to. So this is the depth where we are going to do, and whatever this depth is simply here, this is going to be 3 meters only. So up to that depth we are going to go. Now let's see how to solve the factor of safety. How you are going to find out the factor of safety. First case, so in case A, water table is 5 meters below the ground level. In case A, water table is 5 meters below the ground level. And water table is 5 meters below the ground level means the total depth itself is 1.2 plus 3. So which means if I say water table is 5 meters below the ground level, then it is somewhere. Is it well below the base of footing or just below the base of footing? It is well below the base of footing. So this is 5 meters. Case A, I want to find out in case A, water table at a depth of 5 meters below ground level. So if I say this, first thing first, whatever it is there any change in the ultimate bearing capacity? Is there any change in the ultimate bearing capacity? No change in the ultimate bearing capacity. I want to find out whom? Factor of safety. So whenever I want to find out either factor of safety or depth or width or load, you need to go for the design condition. Design condition. What is the design condition? The design condition is Q less than or equals to QS. Yes. And what is the minimum design condition? The minimum is Q is equals to QS. Okay. So the design condition is whatever the gross pressure that is acting should be less than or equals to the safe bearing capacity. Okay. And what is safe bearing capacity? So I can write here as safe bearing capacity. Q is equals to QS, right? I will take Q as QS. Safe bearing capacity is nothing but net safe bearing capacity plus gamma D from here. Yes, can write like this. And the net safe bearing capacity is nothing but net ultimate by factor of safety plus gamma D. So this is the design condition. What I want is factor of safety. But for that, you need to find out the net ultimate bearing capacity, right? And what is ultimate bearing capacity? Come on, tell me. What is ultimate bearing capacity? The ultimate bearing capacity, is it a square footing or strip footing? Square footing. As it is a square footing, 1.3 times of CNC plus gamma D and Q plus 0.4 gamma B and gamma. So in the case of the water table at the rate of 5 meters below, there is no effect. So no effect of water table. There is no effect of water table. Yes. Now, anyways, from the given data, see, I am following step-by-step procedure. In the following data, I took C dash as 0. So this is going to be 0. Now, what is mean by QNU, sir? What is mean by QNU? QNU is nothing but QU minus gamma D. QU minus gamma D. So what is mean by QNU? The QNU is nothing but QU minus gamma D. So from here, what you can write the QNU, please tell me. So this is 0, gamma D and Q plus 0.4 gamma B and gamma minus gamma D. I can write as gamma D NQ minus gamma D into NQ minus 1 plus 0.4 gamma B and gamma plus 0.4 gamma B and gamma. Okay. So whatever the net ultimate bearing capacity is equals to gamma D NQ minus 1 plus 0.4 into gamma B and gamma. So we have got this. Still, I did not apply any value. Did I? No. Now I can write everything in the one simple equation. So what I know is Q is equals to, what is QNU? Gamma D into NQ minus 1 plus 0.4 gamma B and gamma divided by factor of safety plus gamma D. Yes, that's it. I have written the equation. Now what I require is factor of safety, right? What is the gross pressure I have mentioned you? 350. Come on, substitute. Gross pressure is 350. And I gave you above the water table, what is the unit weight? Above the water table, what is the unit weight? 17. 17 into D value, 1.2 into, what is NQ value? 22. Minus 1 plus 0.4 into gamma, again 17 into B value, 3 into N gamma, 20. Divided by factor of safety plus gamma into D, 17 into 1.2. What about the factor of safety? What about the factor of safety? Come on, tell me what is the factor of safety? Find out the factor of safety. What is this value, please? 350 minus 17 into 1.2. So the answer is going to be factor of safety 2.537 rounded to 2 decimals, 2.54. What is the factor of safety? The factor of safety is going to be 2.54. Okay. So similarly, now what is the difference if the water table is what is the difference that you are going to see? Tell me. What is the difference that you are going to see if the water table is, so what is the second question? Water table is at 1.2 meters below ground level. Array, if the water table is at 1.2 meters below the ground level, this is the place, right? Water table at 1.2 meters below the ground level. So this is case A and this is case B, where water table is 1.2 meters below the ground level. So now if this is the case, what will change? You tell me in the entire equation where you are going to see the change. Only this gamma becomes gamma dash. That's it, right? For case B, water table is at 1.2 meter below ground level, which means at footing level. At footing level. So what would be the ultimate bearing capacity? Come on. The ultimate bearing capacity is nothing but gamma D into NQ only plus 0.4 now gamma dash BN gamma. And for the first question and second question, the only change is this one. Apart from that, is there any other change? Apart from that, is there any other change? Nothing, right? So if this is the case, then you know that what is QNU? Gamma D into NQ minus 1 plus 0.4 gamma dash BN gamma. And what is Q? QNU by factor of safety, gamma D NQ minus 1 plus 0.4 gamma dash BN gamma by factor of safety plus gamma into D. So as I am asking you, above water table, there is above water table, this is gamma. Below it is going to be gamma sat. And already I mentioned you gamma sat as 20. Already I mentioned you gamma sat as 20. Okay. So now, hope you understood the steps. Yes or no? So you have to be habituated with the step. This is square, my dear. This is not a strip. This is a square. So it's not 0.5, it's a 0.4. So now 350 is equals to, again, Above water table 17 into 1.2 into 22 minus 1 plus below water table 0.4 into 0.4 into gamma dash, gamma sat minus 1. So what is gamma sat? I have given you. The gamma sat I have mentioned is 20. 20 minus 9.81 into, what is the B value? What is the B value? 3 into n gamma 20 by factor of safety plus 17 into 1.2. Find out the factor of safety. Hope you got the difference between a question A and a question B, which means soil below footing is under submergence. Everything is same except that. So what is the factor of safety here after solving this? Can you please tell me what is the factor of safety? Why different people has different sir, explain again NQ minus 1. What is this, my dear? Gamma D NQ plus R plus 0.4 gamma B and gamma minus gamma D. Na? So here gamma D NQ, here gamma D. I can take gamma D common. So NQ minus 1 plus gamma B and gamma. Yes. So what is this value, please? $2.04. You see what is happening to the value. So when the water table is well below, the factor of safety is 2.54. But when the water table rises, you know, effective stress decreases, bearing capacity decreases. When the capacity of the soil is decreases, it's the factor of safety is also going to be decreases. Okay. Yes. So that's all for that question. Now, if you have understood this, I'll give you one more question. You try to solve this one. I'll see how many of you will solve this question. Let's wait. Yes. I'm giving you 2 minutes for you. You understand this. First, you read the question. The entire answer lies in the question itself. So you read the question. If you understand the question, then we can go further. Give me a minute. So size of an isolated footing is to be limited to 1.5 meter by 1.5 meter. Calculate the depth at which the footing should be placed to take a load of 1962. So I hope you might have understand the question. If you have, now let's see. So here the size of an isolated footing is to be limited to 1.5 by 1.5, which means it's a square footing. Yes or no? So the size is 1.5 meter and this is a square footing. So immediately in your mind, what formula you have to use? Okay. Calculate the depth at which. So I am asking you the depth at which the footing should be placed to take a load of 1962 kilonewtons with a factor of safety of 3. So I am asking you the factor of safety is going to be 3. Okay. 1962, that's not the end of the question. But here, if you mention, I did not mention anything regarding to either it is gross load or net load. Because you know, when the pressure is coming from the structure, there are two types of pressures. One is gross, another one is net. The soil has an angle of internal friction phi 30 degrees. Given self weight of the footing and the backfill is 5% of the external load. So whatever the external load is nothing but 1962, right? From this. So the load coming from the structure is 1962. Apart from that, you know that at the base, the total pressure is due to external load plus self weight of the soil. And here they have given self weight of the footing also. So I can take the net load is 1962 kilonewtons, whereas the gross load is external load plus 5%. So the gross load is equals to external load plus 5% of the external load. 5% of the external load, which is nothing but 0.2. So now what is the gross load here? The gross load is nothing but 1.05 times of 1962. Two 60.1 kilonewtons. Okay. So the gross load is going to be 2060.1 kilonewtons. That's the gross load. 1.05 into 1962. Okay, fine. Now, if you observe, what I am asking you here is the weight of the soil is nothing but the unit weight. I am asking you the depth. That's it. It's not a design condition or not? Yes, it is a design condition. Once you know the gross load, then what is the gross pressure? The gross load by area, which means 2060.1. Okay, fine. Keep it like that. Anyways, we'll solve, right? So don't worry about this. So again, coming to the design condition, whatever the design condition, you know that Q less than or equals to QS. Q is equals to QS. Now, can I write directly? QS is nothing but QNS plus gamma D, which is nothing but QNU by factor of safety plus gamma D. Yes or no? Array, this is similar to the previous question or not? Is this similar to the previous question or not? Yes. In the previous question, whatever the question I have solved, here I gave you depth, I asked you the factor of safety. Same thing here also. Again, 30 degrees, NQ, N gamma. Is there any C value? No. So now, if you observe from here, can I write the QNU is equals to, should I write everything? Gamma D into NQ minus 1 plus 0.4 gamma B and gamma. Why I have written like this is nothing but C is equals to 0. So now Q is nothing but whatever the Q is nothing but this value. So this is nothing but gross load by area is equals to net ultimate bearing capacity by factor of safety, net safe bearing capacity plus gamma D gross safe bearing capacity. So now whatever the gross load I got is 2060.1 by area. By area. What is area? 1.5 by 1.5. Okay, is equals to gamma D into NQ. So what I have to write is gamma D into NQ minus 1. What is gamma given? 20.6 into D into NQ, 22 minus 1 plus 0.4 into 20.6 into, what is the B value? 1.5 into N gamma 20. By now, what is the factor of safety I have mentioned? 3 plus gamma 20.6 into D. So please substitute and get to know. I hope you got the difference between the previous question and this question. Have you got the difference between the previous question and this question now? In the previous question, I gave you the gross pressure directly. Here, I gave you the load. I gave you external load. Then I asked you to calculate the gross load. Then I am allowing you to calculate the gross pressure. So now I hope you understood the same. Everything at the end, the step is going to be same. Here, this is the same step I used there also. So please tell me the answer. The answer should be some 6.05. It's 0.23. Why you are getting 0.23 there? 5.06 or something else. Tell me the value, please. So you take 3 to the other side, or you know, whatever this value that comes. So 0.4 into 20.6 into 1.5 into 20 by 3. 2060.1 divided by 1.5 into 1.5. Nice answer. 833.2. Okay, so this value. Divided by. So please tell me the D value. What is the D value you got? The D value you got as 5.06. So first we find out the factor of safety, then we find out the depth also. Hope you understood. See, somebody is saying, sir, gross pressure is nothing but load by area plus gamma dina, sir. Are Baba, this load is net load. Okay. And they have given that. So I can write this one. What is the problem in that? Whatever the gross load you see, what is the gross load? The gross load comprises of external load, self weight, and backfill. They have given in terms of load. The total load by area is nothing but total pressure. Whatever I am writing, it's not a net load. Keep that in your mind. Yes. So hope you got this. Now you see the next question. Yes, you see this question, please. A wall footing. What is the meaning of wall footing? What is the meaning of wall footing? The wall footing is nothing but strip footing, right? The meaning of wall footing is nothing but a strip footing. Carrying, now it is clearly mentioned. What is this? Net load. Net load of 152 kilonewton per meter length of wall. See, in the case of a strip footing, as the length is larger than the width, we generally take it as L as 1 meter. Means per unit length. Per unit length, 152 kilonewtons per 1 meter length is to be constructed at a depth of 1.2 meters. Is to be constructed at a depth of 1.2 meters. Subsoil consists of a uniform deposit of a stiff clay. Subsoil consists of uniform deposit of stiff clay. Okay. So now what is the soil mass over here? Simply it is a clay soil. Yes, as it is a clay soil with a unit weight of gamma. How much? What is unit weight? Gamma 18.8 kilonewton per meter cube. And unconfined compressive strength of 150. I hope if you remember in the chapter number 13 shear strength, the unconfined compressive strength is nothing but 2 times of the shear strength. Remember this, which is given as 150. So now can you tell me what is CU? 75 kilopascals. Now you see what I am asking is determine the width of the footing using a factor of safety of 3 using Terzaghis theory. Using Terzaghis theory. Now, whenever you know clay phi is equals to 0 degrees, and as I mentioned, this is nothing but Terzaghi. Terzaghi, for the Terzaghi, you know NC is 5.7. Why? Base is rough. NQ is equals to 1. N gamma is equals to 0. See, I'm going again from basic. If you ask me, the logic is directly I can write out net ultimate bearing capacity is CNC. Yes or no? So you know that QU is equals to, it's a strip footing, right? As it is a strip footing, CNC plus gamma DNQ plus 0.5 gamma B and gamma. So now you know that what is happening? N gamma is equals to 0. NQ is equals to 1. Then QNU is equals to QU minus gamma D. Then what is QNU? CNC. This we know. But what I required is width, right? For factor of safety, load, depth, width, design condition. Come on. If you ask me, I would have solved this one with single step. What is the design condition? What is the design condition? The design condition is Q is equals to QS, means Q less than or equals to QS, right? Yeah. Q less than or equals to QS. Okay, now you observe here. You know that Q is equals to QS, which is nothing but QNU by factor of safety plus gamma D. But in the given question, do I have net load or gross load? Do I have net load or gross load? Net load. So what I will do is, can I write this one as the net load, the gross pressure is nothing but net load plus gamma D. QNU by factor of safety plus gamma D. Yes, I can remove the gamma D on both sides. And then I can write a net load by area is nothing but net ultimate bearing capacity by factor of safety. As simple as that. And what is the net load given? 152 by what is the area of a strip? B into 1, right? The area is nothing but B into 1. So B into 1 is equals to net ultimate bearing capacity. What is net ultimate bearing capacity? C into NC. So C into NC, this is nothing but CNC by factor of safety. Na? So what is C? 75 into NC 5.7 by what is the factor of safety? 3. What is B value? What is the B value? Please tell me. 1.067 meters. Okay. Now, after solving this, can you please tell me, do you feel this concept is typical or do you feel the concept is easy? What I am dealing is simply one concept, the design condition. And you know, one equation, QU is equals to CNC plus gamma D plus 0.5 gamma B and gamma. In that, water table, below water table, submerged. If there is a change in shape, factors will change. I hope you understood. Any doubts? Why I took NC 5.7 as per Terzaghi. So if you have understood this now, let's see this question. It's all about understanding the question. If you are able to understand the question, then the steps are quite simple. What is shortcut? Huh? Shortcut is I can directly write this step. Can I write this step directly? The shortcut logic is, you know, whatever the net pressure should be less than or equals to net safe bearing capacity. That's it. The net pressure is nothing but net load by area B into 1 is equals to net safe bearing capacity, net ultimate bearing capacity CNC for clays, CNC by factor of safety. I can write like this one, right? Can't I? You know, the net safe is nothing but net ultimate factor of safety. I told you clearly in place, net ultimate is CNC. CNC by factor of safety. One single step, khatam. Per meter length. Why I took L is equals to 1 is per meter length. Per meter length. Because the load is given as per meter length, right? 1 point. That's a wall footing, na? You see here. Listen to this. This is also one of the beautiful question. Question is beautiful. If you understand, the answer is very, very simple. Okay. So a building has to be supported on a RC raft foundation of dimensions. A building has to be supported on a RC raft foundation of dimensions 14 meters by 21 meters. So raft, now you tell me 14 meters by 21 meters. Is it a rectangle or strip? This is a rectangle. Okay, fine. The subsoil is a clay soil. Very good. So we got to know what type of footing we got to know, and we got to know what type of soil. Having average unconfined compressive strength. Again, the unconfined compressive strength is nothing but 2 times of the undrained shear strength, which is nothing but 15 kilonewton per meter square. So what is CU value? The CU value is 7.5 kilopascals. Okay. Now, from here, the major thing. Now, I'm providing a raft foundation. Na? Yes, the pressure on the soil due to the weight of the building and the loads that it will carry will be. The pressure on the soil due to the weight of the building and loads that it will carry will be 140 at the base of raft. And the building has a provision for the basement floor. Now, can you please tell me, does this 140 is a gross pressure or net pressure? Think and say. Think and say. Whenever I provide a provision for the basement floor, you know the meaning of the basement floor. In the case of the basement floor, if you provide a basement floor on the raft, is there any self weight of the soil? No. Whatever the pressure acting at the raft is simply the pressure coming from the structure. Yes or no? Think and say. Whenever I told you, whenever you provide a raft, it means we discussed about compensated raft, right? Let's go back to the compensated raft. Yeah. Please observe this. Whenever I provide a raft, see, this is nothing but a raft. Yes. But here I am not saying about it's a compensated. So now can you please tell me what is the total gross load is nothing but whatever the load coming from the structure is nothing but the gross pressure. Yes or no? Because there is no backfill. When there is no backfill, then what is the Q value? If you would have understood this point, then answer gone. Hope you got this point. Yes or no? So once you got this point, now what I'm asking is at what depth should the bottom of the raft be placed? So I am asking you, what is the depth? I'm asking you, what is the depth? What is the factor of safety I have provided? Factor of safety is 3. Gamma is 19. But this time I am giving you Skempton's approach. You know, simply the Skempton's approach is there. Depth, width, factor of safety, load, design condition. Now, what is the design condition? Q less than or equals to QS. Q is equals to QS. And what is QS? Net safe bearing capacity, which is nothing but net ultimate bearing capacity by factor of safety plus gamma D. And you know that for clay, the net ultimate bearing capacity is CNC. As simple as that. It is CNC by factor of safety plus gamma D. It's all about the NC. Yes, it's all about the NC. This time I should not apply the NC directly as 5.7. This is given as whom? Skempton. From Skempton, QNU is equals to CNC, but that NC, you know that 5 into 1 plus 0.2 D by B into 1 plus 0.2 B by L. I want D. As it is a rectangle, I am using 14 meters by 21 meters. As it is a rectangle, I am using 14 meters by 21 meters. So now you see what is the net ultimate bearing capacity here. So what is C value? The C value is 7.5. Have you understood this logic or not? Here it's all about whatever the given load, is it a gross or net? Think. If you get it done, then answer is done. Sir, how did you say there is no backfill? That's what, my dear. There is a basement floor. What is the meaning of basement floor? This is the meaning of basement floor. Basement floor is nothing but cellar. In the cellar, are you going to see any soil mass? In the cellar, are you going to see any soil mass? No, right? This is nothing but raft, right? Raft. So 7.5 into 5 into 1 plus 0.2 into D by, what is B given? 14. Into 1 plus 0.2, 14 by 21. So this 1.2 into 14 by 21 by 21 plus 1 into 7.5 into 5, 42.5 into 1 plus 0.2 by 14, 0.0143 D. So I can write as 42.5 plus 0.607 D. That's it. Now you please substitute over here from this equation. What is Q? 140 is equals to 42.5 plus 0.607 D by factor of safety given as 3 plus 19 into D. Get the D value. Take the LCM. Take down the LCM. That's it. So 0.19 is 7. One 40 into 3 minus 42.5 by 57.06. The answer comes as 6.55 meters. Hope you got this right. It is 2 marks question only. It's 2 marks question. It's not 1 mark question. Don't expect these type of questions as 1 mark. The design questions, all the design questions are 2 marks questions only. All the design questions are 2 marks questions only. Okay. So now with this, we discussed about Terzaghi's theory and we discussed about Skempton's theory. We'll see one more question regarding to Meyerhof. Sir, 1980 should not be there. No, sir, because of no backfill. Arey Baba, what is the meaning of this one? What is the meaning of this one? Whatever the no backfill is there, but previously it was backfill is there, right? Before construction, there was there, na? Before construction of the structure, there was a backfill. Means that's nothing but self weight. The gamma d is self weight over here. Okay. Now you see this question. Again, footing is a square 2 meter by 2 meter. Subject to an inclined point load. Okay. Whenever the inclination comes into existence, who will come into the existence? Meyerhof. And you see, I have given all the factors also. Okay. And the water table is located at well below the base of footing. This is GATE 2014, my dear. This was asked in GATE 2014. Even in recent 2019 or 2018 also, they have asked one more question similar to this. Water table is located well below the base of footing. Considering one-way eccentricity, which means one side only. The eccentricity is one side, which is nothing but so they have given. So you please observe what is the one-way eccentricity over here. Come on, tell me. So this is center, na? Then what about this is nothing but Ex. So you know that whatever the given from the figure, B by 2 minus Ex is nothing but 0.85 from figure. B by 2 minus Ex itself is a 0.85, right? Yes, yes. Okay. Now, the net safe load carrying capacity of the footing for a factor of safety of 3. I am asking you what is the net load safely that you are going to apply. I'm going to ask you net load. The net safe load means the net load that you are applying safely. Safely means you are applying factor of safety when condition comes into the condition. So now I am going to find out the net load. What is the factor of safety? The factor of safety is 3. Okay. So I want to find out the net load. Okay. So forget about the remaining things. First, immediately in my mind, net load, net load, net load. Okay. What is design condition? What is design condition? I can directly write that. Either I can write gross pressure should be less than or equal to safe bearing capacity, or net pressure should be less than or equal to net safe bearing capacity. Yes or no? What is the net pressure? Net load by area is equals to net load by area is equals to net ultimate by factor of safety plus gamma d. Oh, sorry, no gamma d. Net ultimate by factor of safety, because net safe bearing capacity is nothing but net ultimate by factor of safety. Everybody understood, right? Up to this point, any doubt? Now, let's see. Mr. Srinu Grizala, so B less than L and B dash greater than L dash, then what should we use in the equation? That will not happen, Mr. Srinu. You asked the same question while I was discussing. That is the reason why I didn't react. That will not happen. Whatever the shortest dimension only you have to take. Okay. So now, as it is eccentrically loaded, now you please write down the equation of QU. Please write down the equation of QU. What is QU? CNC plus gamma DNQ plus 0.5 gamma B and gamma. Okay. But as clearly mentioned, if you observe over here, NQ and gamma is given. FSQ and FS gamma, which means factor of Q, SQ, S gamma shape factor is 1.314. Similarly, here FQD, FD gamma. So DQ is equals to D gamma is equals to 1.113. Similarly, IQ is 0.444. I gamma is 0.02. Okay. So SQ, S gamma, DQ, D gamma, IQ, I gamma. Now, you please observe, this is SC, DC, IC, SQ, DQ, IQ, S gamma, D gamma, I gamma. Now, you see, in this case, I clearly mentioned C is equals to 0. When C is equals to 0, this entire term gone. Yes or no? Now Now you find out the ultimate. What I required is net load. Na? I know the condition. Yes. And as you know, as it's a one-way eccentricity, you know that this is nothing but A dash. So I have to take A dash as B dash into L dash. Yes. Wait for that. Because of the one-way eccentricity. Okay. Now, what is QU? QU is nothing but gamma D. There is no water table. Gamma into D. Gamma. What is gamma? 18. And what is the depth? The depth of the foundation I have given as 1 meter. Unit weight of soil is 18 kg per meter cube. B by 2 minus EX is nothing but 0.85. Okay. So now gamma 18 into 1 into, see how to do the calculation carefully. NQ 33.3 into S. So these are gone, right? S. Okay. NQ. And what is SQ? 1.314. What is DQ? DQ 1.113. What is IQ? IQ is nothing but 0.444 less 0.5 into 18 into B value. What is the B value? The B value is given as 2 meters, right? Very good. Should I have to apply this one as B or B dash? Due to the eccentricity, should I have to apply it as B or B dash? B dash. Now, what is B dash? B dash is nothing but 2 times of B by 2 minus EX. 2 into 0.85. I can write as B dash as 1.7 meters. Yes. Or you know B dash is nothing but B minus 2 EX. You know B by 2 minus EX. You can find out EX and you can find out B dash. Yes. So this B by 2 minus 2X is nothing but 0.85. From there I can find out B dash directly. As it is one way. Sir, square footing na? Okay, my dear, what is Sujana? I told you when you are providing the shape factor, then why you are going for 0.4? That's what I mentioned. What is mean by yes? That is nothing but shape. You don't write that. 0.5 into 18 into 1.7. And what is L dash? One way eccentricity. L dash is nothing but same because of one way eccentricity. Okay. So 1.7 into N gamma. Now what is N gamma? 37.16 into S gamma 1.314, D gamma 1.113 into I gamma. What is I gamma? 0.02. What about the ultimate bearing capacity? What about the ultimate bearing capacity? 18 into 1 into 33.3 into 1.314 into 1.113 into 0.444 plus 0.5 into 18 into 1.7 into 37.16 into 1.314 into 1.113 into 0.02. So this comes as a 405.84 kilopascals. That is QU. And once you know this, then you can find out the QNU. What is QNU? The QNU is nothing but QU minus gamma D. So the net load by area B dash into L dash is equals to QNU is nothing but QU minus gamma D by factor of safety. I want the net load. So 1.7 into 2 is equals to 405.84 minus 18 into 1 by what is the factor of safety? The factor of safety given as a 3. So a lot of people might got a question. Sir, here why you are not writing gamma D NQ minus 1? Gamma D into NQ minus 1, why you are not writing? It's not gamma D into NQ minus 1. Here this entire form is there. If you write minus gamma D, then gamma D into NQ, SQ, DQ, IQ minus 1. So come on, tell me the value. What is the answer? 439.56. And the answer was given as range. 438 to 442 kilonewtons. This was the answer given in the GATE 2014. You tell me now, is there anything that you feel complex over here? If there is a one thing that you feel complex, that's a calculation, not the concept. The concept is crystal clear. I have solved every problem, and you see, you go back to the every question. The concept that I used is design condition, this one. Apart from that, I am not using anything. I'll write the design condition, and what I required, I'll see that. Further, I'll find out the ultimate bearing capacity. So tell me, are you feeling it is easy or difficult? I want, and it's been a long time. So what difficult? I mean, it requires some practice, that's it. But I can tell you, this is one of the very easiest topic, the shallow foundations, very easiest topic. It's all about, like, you might feel some difficulty in calculation. If you do something wrong in calculation, then gone, khatam, ho gaya. Okay, so with this, we'll stop the class session for now. I'll take some doubt clearing session. QE is wrong. Huh? I mean, I think I calculated correct value only. Is it true? Does QE is correct or any wrong is there? Correct only, 405.84. Okay, fine. So now let me allow the students who are having doubts, who are eagerly waiting. Mr. Dilip Kumar, you can speak out. Mr. Dilip Kumar. Mr. Chinmay. Mr. Chinmay, you can speak out.
Yes, sir. Sir, I have doubt in Boussinesq's line load, sir.
Okay, tell me.
Sir, that means we can find x only perpendicular to that line. Sir.
Yes.
Means
Yes.
if it is inclined, then we can't find.
No, it's it's not. If it's inclined, we cannot find.
Also, sir, in that stress distribution, sir, you told that means sigma z variation on vertical plane.
Yeah.
Sir, that I don't understand. Means it's means its maximum it's below that line.
No. What I am asking you is it vertical line below the load of action or with some radial distance r?
With some radial distance.
With some radial distance r, if you see that equation, in that equation, so in that equation sigma z is there, right? That's going to be directly proportional to z square by r square plus z square whole to the power of 5 by 2.
Yes, sir. Z cube.
Yes. So here,
yes.
Sigma z is a function of z and r both. In numerator is there, in denominator is there. R is not 0, z is not 0. Yes.
Yes.
So here I cannot say directly whether the value increases or decreases. But for various values of r comma z, it was observed that if you take any plane, first at lesser depth, you see at lesser depth, the stress is going to be increases, reaching maximum. So this is a maximum value. Okay. And as a depth value is going to be increases, at some point it starts to decrease and decrease and decrease, again becomes minimum. So yes, in this case, there is no peculiar variation. So that's the reason why from various values of r comma z, if you substitute r comma z also, we get to know that First it increases, reaching maximum, and then decrease. Okay.
Okay.
Yeah.
And sir, in shear strength chapter, we saw that at some points before the maximum shear stress only soil fails, sir.
Yes, it can fail. There is no hard and soft rule like the soil should reach definitely its maximum shear stress. There is some soil. If the soil is weak now, if you
Okay.
apply small load, also soil can fail. Yes.
Okay.
Yeah.
Okay. Thank
Yeah.
you.
Yes. Miss Ikra, you can speak out now.
Good evening, sir.
Good evening.
Sir, I still did not get why are we considering gamma D in draft foundation.
Gamma D draft foundation.
So the ESC question we did.
This
Yes,
question. Yes.
yes.
What is the meaning of safe bearing capacity?
The capacity with which the soil will not fail.
Huh?
Within which the soil will not fail.
First of all, what is mean by ultimate bearing capacity? From there you can get to know. Whatever the load that comes, that is comes out of Q. Yes or no?
Yes, sir.
Okay. What is mean by ultimate bearing capacity?
The maximum capacity of soil or the maximum load it can take.
From the gross pressure. Okay.
Yes, sir.
But already this soil in past it has been experienced gamma D, right?
Yes, sir.
Yes or no? So
Yes,
what
sir.
you are saying is, sir, present there is no gamma D. Now why you are adding? Yes. But
Yes,
what
sir.
I am saying is already this soil has experienced gamma D earlier. So let's say gamma D is 50. Okay.
Okay.
Now this Q, it's 140. I don't care whether the 140 comes from only structure or I don't care whether the 140 is coming from a structure plus backfill. I don't care about that. What I do care is at the end of the structure, what is the total pressure acting on me? 140. Yes.
Okay, sir.
Out of that 140, already I felt 50 in the past. Yes.
Okay, okay.
Now you got the point.
Yes, sir. Yes, sir.
Now you tell me what is net ultimate bearing capacity. Now you tell me you already now you are feeling 140. That's ultimate. But
Yes, sir.
already in past you felt 50, right?
Yes, sir.
So now what is net ultimate? You can
140
feel
minus 50.
90. Yes.
Okay, sir. Okay.
This is nothing but gamma D right now.
Okay.
Now you got?
Yes, sir. Thank you.
Yeah. Mr. Imran. Mr. Imran.
Good evening, sir.
Good evening, Imran.
Sir, in triaxial test, the resultant horizontal confined pressure is 0. So, how the shear stress we are considering only from one side?
See, shear stress is not considering one side. You are making that earlier both are same. Yes or no?
Yes, sir.
Earlier both are same. So now what I am doing is I am not increasing on the confining. I am increasing the axial so that I am making this one as major principal stress. This is minor principal stress. So when you make the stresses different, then only the shear stress will develop. Now what is the shear stress? Sigma 1 minus sigma 3 by 2 sine 2 alpha. Yes.
Yes, sir.
If you apply both are confining pressure, then where is the shear stress? So if you want to create a shear stress on any plane, you should make sure one is major and other is minor. Yes.
Yes, sir.
So for that, I am applying an additional load on the axial direction. That will increase the major principal stress slowly. Then the shearing will start on any plane. And as you increase this deviatrix stress more and more and more and more, the shear stress will increase as more and more and more and more, and finally reaches the failure.
Okay,
Okay.
sir.
Yeah. Miss Sujana. Miss Sujana, you can speak.
Hello, sir. Good evening.
Yeah, yes, tell me, Sujana.
Sir, in inclined backfill, sir, K is equal to, have given some formula cos beta into the thing, no, sir? Then KP is equal to, should be 1 by cos beta, isn't it?
I don't
1
get.
by, sir, Ka formula you have given as cos beta
Yes,
into
yes,
cos
yes,
beta minus.
yes.
For KP, why isn't it only the fraction part is inverse and why not cos beta, sir? It should
1 by cos
be,
beta you read. No, you say, okay, fine. You are saying now 1 by cos beta. What is cos beta?
So beta is the angle.
That's not simply like that. You cannot say that's a derived formula. That's we derived that and we got that. Okay. I am not showing you the derivation because if I show you the derivation, that will mimic your mind. So forget about the derivation.
Acha, okay, so.
Okay.
Sir, and one more thing, like you said that unsupported depth of excavation is only an active case, right? Sir, why what it physically means that it doesn't present in like passive state, sir.
It doesn't passive state means in the case of the passive state, there is no negative pressure, right? In the case of the passive state, from top to bottom, always there is a pressure, na?
Sir, one thing in passive state, as the load is increasing, then vertical load should be maximum, no, sir. Like you said that while the load is increasing, vertical, I mean passive pressure, passive state exists, plastic equilibrium condition exists. But as the vertical load is increasing, with sigma v will be the maximum plane, no, sir? No, isn't it?
I did not say that as vertical load increases. When the soil is moving downwards, okay, means here the soil is moving upward. It's not meaning of vertical load is increasing. Soil is moving upward, and that soil movement is going to be resisted by the resisting force of the soil mass. So where I said the vertical load is increasing, tell me. You see,
Sir, in foundation topic only, sir, while load is coming onto the soil, passive
retaining
state.
wall is different. See, in the case of retaining wall, it is different. In the case of the footing is different. Wall, the movement is lateral. Yes.
Yes, sir.
Footing, the movement is vertical.
Okay, sir.
Understood?
Yeah, yeah,
The
sir.
wall, the movement is lateral. In passive state, lateral force is more. In footing, the movement is vertical. So in passive state, vertical load is more, right?
Yes, sir. Yes, sir. I got. Sir, and one more doubt.
Yeah.
In stability of slopes topic, sir, could you please tell what the, I mean, for shear stress calculation, I mean, why should we consider only the total pressure, sir? Why not effective?
Actually, see, in the case of the seepace, while the seepace is happening, due to seepace pressure is there, right?
Yes, sir.
Seepace pressure acts into the shear stress only, no? Yes, sir.
Yeah, yeah, sir.
So that will increase the pressure. That's the reason why we take gamma sat. In the vertical, it is gamma sat minus gamma W submerged. Yes.
Yes, sir. Sir,
But
but like why
let me tell you,
pour pressure? Okay, sir.
let me tell you. So due to this seepace pressure, it makes not only the submerged shear stress, but also the seepace pressure. Submerged is gamma dash into Z. Yes.
Yes, sir.
When the seepage is coming, it is going to be create gamma W into Z. Yes.
Yes, sir.
Now you please add both. What will be there?
Yes, sir.
Understood or not?
Yes, sir. I got. Sir, and one last thing. In pi is equal to 0 analysis, sir, there you have written like MD is equal to W into some X, no, sir. That X is extended till where? I didn't
With
get that
respect to
in
center,
detail.
I told you, right? With respect to center. You
Achha,
keep
okay, sir.
with
Yeah,
respect-
yeah, okay, sir. Okay, sir. Okay, sir. Thank you, sir.
Okay. Next, Roshan Dilip.
Hello, sir.
Yeah, Roshan Dilip, tell me.
Sir, in that eccentric loading, I didn't understand that.
Dilip, I'm not able to hear your voice properly. Can you speak loudly?
Sir, in that eccentric loading, can you repeat that? How to do the conversion? I didn't get that.
So you want me the conversion, yes?
Yes.
This one, right?
Yes, yes.
See, this center, this is a load acting, yes? What is this width here?
B by 2 minus EX.
Up to center, it is going to be B by 2 minus X, yes?
Yes.
So up to center, B by 2 minus X. Then what is B dash? 2 times of this value, right?
But sir, that should not necessarily be at the center, right?
That's what now. What is the meaning of that? Eccentrically loaded is transformed into equivalent concentrated load. What is the meaning of concentrated load? This load should act as a concentrated load. Yes.
Yes.
What is the meaning of concentrated load? Load should act at center.
Oh, okay, sir. Yeah.
Okay.
Sir, then Q and P, right?
Huh?
Net safe settlement pressure, right? Q and P.
Yeah, yes.
Sir, does that come with factor of safety?
Does that?
Is factor of safety
Yeah,
included?
yes. There also comes with the factor of safety, but there is no peculiar calculation for finding the net safe settlement pressure. As most of the soils fails by shear, na? I told you one point that. Yes.
Yeah, you told me.
Yeah. Okay.
Okay, sir.
Sanket. Mr. Sanket.
Hello, sir. I'm audible.
Yeah, you're audible.
Sir, the water table reduction factors of the RW1.5 and RW2.5. Could you explain, sir? I didn't get properly.
Okay. If you substitute JW as 0, you substitute here.
So the values of JW1 from where it is can
JW and JW2. JW1 are going to be take between ground level to footing. Yes.
where
Okay.
water table is at ground level.
Yeah, you see here, what is JW1? Yes or no? What are you able to see this one? Yes.
Yeah.
Okay, fine. So now let me take this one. Yeah, I can write over here. What is JW1? JW1 is nothing but depth of water table between ground level and footing. Okay.
Sir.
And what is JW2? Depth of water table below footing. Okay. So now you tell me what is JW1 maximum depth between ground level to footing means if the water table is at ground level, JW1 is 0. Yes.
Yes.
If the water table is at footing, then what is the maximum value of JW1? D only.
1. Yeah.
Yeah. So now you come over here, you substitute that D value. If JW1 is 0, 0.5. JW1 is D by D1, right?
Yes.
Now I hope you got it. Yes.
0.5. Yeah.
Okay, fine.
Thank you, sir. Sir, like this problem, the RW1, RW2 problems.
Yeah, they would be asking for one more question. Water table correction factor, they will be asking.
Especially they will give mention in question.
Yeah. In the question, they will mention find out the water table correction factor.
Okay, sir. The gate problems will you take tomorrow, sir?
Yeah. Today I was taking this classroom practice questions only. Tomorrow there is only one topic left over in this chapter, plate load test. So after that topic, some miscellaneous small topics are there, 2, 3.
Okay,
And tomorrow we'll see the previous gate and DSC questions.
sir, after this class, continue will be started by offline class now. We are offline batch students.
Yes, it will continue. From 5th onwards, the continuous will be there.
Okay, sir. Thank you, sir.
Next, Mr. Rohit.
Sir, near stress path, you told one thing, sir, like if footing is there, the load coming from footing is varying, so vertical stress will be varied, whereas horizontal stress won't vary, you told, no, sir.
Yes.
Sir, but if vertical stress varies, horizontal will also vary, no, sir. Due to sigma V is equal to K into sigma H is equal to K into sigma V, no, sir. So if vertical varies, then horizontal will also vary, no, sir.
When do you say the lateral pressure? What is meant by lateral pressure? What is meant by sigma H? Tell me first of all.
The pressure horizontal direction, lateral pressure, sir.
Where it is going to be acting? On wall.
Yes, sir, on wall.
When you see on wall, it is increases. But beneath the soil, if you see laterally, it is going to move the wall, move the soil only, right?
Yes, sir.
Then how come it is going to be increases? Tell me.
But vertical stress is changing, no, sir.
Vertical stress is changing, fine, but I am confining the below soil mass. There is nothing. See, if there is some vertical wall there below the footing,
Yes, sir.
if there is some vertical wall, then the soil exerts a pressure on the wall laterally. Then the pressure may increases or decreases. Yes.
Yes, sir.
So you see the concept clearly. Why the lateral earth pressure increases or decreases? I wrote a points clearly when the wall moves. Yeah, what is that? For active state and passive state, I have written right.
Yes, sir.
You see here why the pressure is going to be increases passive state, because when the wall moves towards backfill, then what is happening? There is actuating of the soil element. Soil will move upward. If there is no wall, then how come the soil moves laterally? Understood or not?
Yes, sir.
Yeah, that's why.
Sir, but here I got one more doubt, sir. Like resisting force develop downward direction. How resisting force influences wall pressure, sir?
Obviously, na. See, you observe here. When the wall is moving, this wall tries to move the soil mass upward. Yes.
Yes, sir.
But what is the resisting force doing? Resisting is saying, why you are coming up, you go down. I am going to pushing you. Yes.
Yes, sir.
On one side, wall is pushing the soil. On the other side, soil is resisting also pushing the soil, so that the soil will get confined. It's just like you are here. From one side, one person is pushing you. On the other side, the other person is pushing you. Okay.
Yes, sir.
Now you are under compression or not?
Yes, sir.
When you are under compression, you are trying to pull out. Yes.
Yes, sir.
You give some resistance. When you are giving some resistance, which means you are applying more pressure on both people. Yes or no?
Due to both the direction, we are applying same
Yeah.
direction forces. Sir,
One side wall movement, other side resisting. Both are confining the soil. Both are confining the soil. Then the soil will feel more pressure. Okay.
yes, sir.
Then it will
Sir,
exert
but-
more pressure on wall.
Sir, how this resisting force is developing in stepwise manner, sir? That means
Yeah, slowly it will increase. It will not increase directly. Slowly, see, if the soil moves less, then the resistance develop less. If the soil wants to move on more, then this resistance, it's just like, see, if you are coming, if somebody trying to resist you, the more you move, the more they will resist. Yes or no?
yes, sir.
Till the maximum resistance they can offer. Yes?
Yes, sir. Till maximum resistance means full failure of soil, I can say, sir.
Yes. And once the maximum resistance attained, till the soil tries to move, then soil will fail. That's what becoming maximum reaching plastic equilibrium.
Yes, sir. Sir, here I can say that like maximum angle at which soil can stand is the angle of repose, I can say, sir.
The maximum angle is angle of repose only.
That means critical angle is angle of repose. After, if you increase
Percent.
more than,
For sand.
for other soils, it is not angle of repose, sir.
For other soils, it's not angle of repose. For clays, there is a cohesion, no?
Yes, sir. Except
Due
for
to cohesion,
clays,
it can be vertical. That's what we said. What is the meaning of critical height of excavation?
yes, sir. For clays, it is different. Rest all soil, I can say angle of repose, sir.
Yeah.
Okay, sir. Thank you, sir.
Yes. See, probably we will be completing the syllabus on Sunday. No, not Sunday, Saturday, and Sunday we'll be having ESC session. Because tomorrow, Tuesday, we'll be completing the shallow foundations. And Wednesday, Thursday, Friday. 3 days are there. Those are for the pile foundations. And Saturday, we'll take a class from 2 to 5:30. In the 2 to 5:30, 2 hours is allocated for the soil exploration. So with that, we'll complete the GATE syllabus. And on that day, the remaining session, the later session, will solve GATE 2020 and GATE 2021 question paper regarding to the geotechnical engineering. So that's how I planned. And by Saturday, we'll be completing the GATE syllabus. And Sunday, as usual timing, 2 to 8:30, we'll go for the ESC. So whatever the remaining topics in that session, we'll be completing, because the remaining topics are small topics for ESC that will be completing them. Okay. Now, Mr. Rudra Jyoti Nanda.
Yes, sir. Am I audible?
Yes, you're audible.
Hello.
Yes.
Sir, can you explain once again, why we are considering NCC and loose sand similar and OCC and dense
What is
sand
meant by
similar?
NCC? What is meant by NCC?
Normally concentrated clay, like
Mean by that? The soil
normally
is undergoing consolidation, or the soil got consolidated under
Yes,
present
sir.
stress or not?
yes, sir.
Which means the soil has more compressibility yet. So whatever the load that you applied it in the past, that load has consolidated little bit only. As the soil has more compressibility, it started to consolidate it under the present stress also. Understood?
Okay.
If the soil has an ability to undergo compressibility, you tell me, Is it going to have more compression? Is it going to have more ability to undergo compression or less ability to undergo compression?
More ability to undergo compression.
Compared to OCC. Yes.
Yes, sir.
That's the way. In the same way, does loose sand
Okay.
has more ability to undergo compression?
Yes, sir. Understood, sir.
Yeah.
Yes, sir. Understood, sir.
Okay.
Sir,
okay.
one more question is there, sir. What is the maximum value of stability number? Like why it is 0.261?
0.261. That is for beta, means phi is equals to 0 degrees. For phi is equals to 0 degrees means for clay soil. In the case of the clay soil, the
Okay.
slope can be vertical, right? In the case of the clay soil,
yes,
the
sir.
slope can be vertical. Na? That's the maximum angle. See, in the case
Yes,
of the
sir.
clay soil, the I value is 90 degrees, right? Phi is equals to 0.
Yes, sir.
That's a clay. And if you see, that's the maximum Meson value is 0.261.
So like it is experimental.
Yeah, it's experimental. That was
Yes, sir.
given. You know, I comma phi m value is there, right? The table is there, na? I comma phi m.
Yes, sir.
So from there
Yes,
you
sir.
got that.
Yeah, yes. Sir. Okay.
Okay,
sir,
see, you see this whatever is that yeah. So you see this one, right? Similarly, when phi is equals to 0
Yes, sir.
degrees, I is equals to 90 degrees, the SN value is maximum of 0.261. Okay, that's it.
Okay, sir. Okay, sir. Thank you, sir.
Okay. Yeah. Mr. Rahul Soman, the last call for today.
Hello, sir.
Mr. Rahul Soman, tell me, Rahul.
Hello. Sir, actually, I have one doubt on one problem.
Yeah, tell me.
On chapter 13, shear strength. It was before the topic modified failure and
Okay.
after this, sir, after this.
After this. Sorry.
Sir, one impairment
Got
problem.
stuck up. App got stuck up. So can you tell me the question? What's the problem?
Sir, in that problem, while finding out, we need to find out the shear strength at the base of the impairment.
Oh, okay, I got it. No, tell me.
Sir, in that problem, shear strength is equal to C dash plus sigma dash tan phi. For
Yes.
finding out normal stress, we need to use the other equation also. That means sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 cos 2 alpha. We need to
You
use
want me
that.
to use that?
Sorry, sir.
You want me to use that?
Sir, actually, in this problem, we have actually just means we have done 5 gamma plus 3 gamma. That means we have just multiplied gamma with height and directly find out normal stress.
Rahul,
Actually-
I'm sorry, I'm not able to hear you and I'm not able to follow you also. I'm not able to understand what you're saying. So can you please say it loudly?
Sir, can you hear me now?
Yeah, I can hear you. So what's your problem here? Tell me.
Sir, we need to find out a normal stress now, sir, while finding out shear strength.
Yes, yes, yes.
Sir, for finding normal stress, we actually use this equation now, sir.
So you are saying that for finding the normal stress, I am using the major principal stress, minor principal stress concept. Yes?
Yes, yes, sir.
If you use that, then where you are going to apply the pore water pressure? Tell me. You have to apply the pore water pressure, right?
Yes, sir. Yes.
Where you are going to apply the pore water pressure? Number one. Number two is, see, they clearly mentioned that assume that dissipation of pore pressure during the stage of construction is negligible, which means there's an under-end condition. Yes?
Yes, sir. Yes.
So I'm asking you immediately after placing this 3 meters.
Okay, okay.
So whatever the 5 meters I constructed long back,
Yes.
now I am adding extra of 3 meters only. So due to that 3 meters, there is an increase in lateral and vertical. Okay.
Yes, sir.
So the way that you said is not the correct way.
Okay.
Yeah.
So we just need to add that only.
Yes, yes.
Vertical.
Yes.
Okay, okay.
Okay, okay.
Okay, sir. Thank you.
Yeah, so for today, done. We'll meet tomorrow. Take care. Good night.